So again, I'm Rob Peterson from the California Public Utilities Commission, Energy Division, and welcome to the Electric Grid Education and Outreach Workshop for the High Distributed Energy Resources, or High DER, Grid Planning Proceeding. Joining us today are staff from the California Energy Commission, employees from PG&E, Pacific Gas and Electric, Southern California Edison, and San Diego Gas and Electric utility companies. Also, Dr. Lorenzo Christoph will be presenting some training on alternative distribution system operations models, and leadership from both the CPUC Utilities Commission and Energy Commission are here today. Again, this event is being recorded, and that recording will be made available. To those who can't hear anything, we did some testing. Please let me know if others can't hear anything. If not, maybe adjust your settings to the extent you can. So some logistics. Everyone has been muted to start, and at certain periods you'll see slides or will be asked if there are questions, and you can raise your hand. One of the panelists or I will unmute you so you can ask the question. You could also put in written questions. We ask that you use the QA function. It's different than the chat function. So Q&A, you'll ask a question or make a comment, and we'll remind it. And then one of the panelists will answer. Everyone should be able to see the questions and answers, and let me know if otherwise. And for chat, just use chat to talk with the panelists. You know, if you have questions about logistics, sounds, logging in, whatever it may be, use chat for that feature only. And then finally, there's a link to a form for a survey. You can see the link here. Hopefully you have the slides in advance. If you're on the service list for the high DER proceeding, you would. Matthew shared a link to GridWorks website in the chat, and he sent it to everyone. Hopefully you should see it. If not, let us know. You can use Q&A for that, would be a reasonable, or maybe use chat. I guess that's legit. That's an example of logistics. So let us know. And then on this GridWorks website, you can find the different presentations for today, as well as the agenda, which was part of a ruling that was issued on August 12th. The ruling has an attachment A, which is the full agenda for today in it. It also has details about joining in this particular WebEx. So today we'll be covering, an introduction, which I just presented. We have some opening remarks from leadership, Commissioner Houck from the Energy Commission, from the Utilities Commission, and Vice Chair Gunda from the Energy Commission. We'll give an overview of two proceedings. One of the proceedings at the Public Utilities Commission, high DER proceeding, and also a DER informational proceeding at the Energy Commission, and we'll be giving an overview of both, and the CEC will be talking a bit about how they relate and how we'll be coordinating. A good portion of the morning is focused on education for stakeholders to prepare them for participating in this proceeding, especially with track 2, which looks at distribution systems operations models. After the training on electric grid, how the current grid is operated from the utility companies, and then alternative grid operations, a potential future grid by Lorenzo Christoph, hopefully you'll have an idea of how distribution system operations works and could change in the future. We'll break for lunch. We'll complete the educational components, which will have a Q&A and stopping points, so it's interactive. And then at the end, in the afternoon, we'll spend some time talking about an outreach plan and ongoing education plans, which are new, which we are presenting for comment, and hope to get some good discussion and feedback going about the outreach plan that the Public Utilities Commission is proposing, especially for track 2 on the distribution systems operations model. Also, I just want to note that the workshop comments, questions, survey responses, all of those things that are part of today's workshop are considered informal comments. And the purpose of providing comments and asking questions today is to help all attendees and stakeholders formulate their written comments about this, the new proposal on outreach, the outreach plan that's being presented this afternoon. Following this workshop, formal comments are requested. The formal written comments are due on August 31st, and reply comments are due on September 9th. These dates were established in that same August 12th ruling, which has the agenda for today as an attachment. And it's 9:05. We're on time. I'm just going to make sure I've got my speakers lined up here for the next section. I see Vice Chair Gunda has joined. I'm looking for Commissioner Houck. I'm going to check and see if there's some trouble logging in. Vice Chair Gunda, would you mind going first? Would that be okay?
Yeah, absolutely. Thank you. Good morning, everybody. Again, this is Siva Gunda, one of the commissioners from the California Energy Commission, and I have the privilege of working on reliability, resource planning, but also broadly the distribution energy resources that falls within that, and equity. So this is an important workshop for me, both from the topics that I cover, but also the importance and the core mission that we all want to work on. So I want to begin by thanking everybody who are in attendance today, taking their time to both learn and be a part of this conversation. Want to extend my thanks to Commissioner Houck for not only welcoming CEC to join this workshop, but to really help with coordination of efforts between the two agencies on this specific topic. Also want to extend my thanks to CPUC staff, particularly Rob, for their tireless work in ensuring there's a lot of staff to staff coordination, which is not always easy, but really appreciate the work that is being done. I want to just offer a few perspectives as we go into this, just the top line of the value of the distribution side. As most of you know, we have done our preliminary analysis of SB 100 and published it last year, and it calls for an incredible amount of resource build. It's looking at quadrupling, almost going 6 times at the pace of what we are building right now in certain years as we move forward. And it means a lot of land use, a lot of coordination between permitting, interconnection, supply chain, as we are all hearing about reliability. It's a lot of work to make that happen. One of the things that's missing in SB 100 is really looking at the value of the distribution side. SB 100 really looked at, what if we met most of the demand with just the bulk side. So this proceeding and the work at CEC really are looking at the opportunity to optimize and coexist, the distribution side innovation as well as the bulk side, to really help understand the value on both sides in terms of reliability, resiliency, but also our core mission of clean, reliable, and affordable energy to all Californians. So as we move towards better coordinating and really pushing forward on the distribution side, I want to just offer a couple of perspectives from the IPER process, which is the Integrated Energy Policy Report that the CEC develops every year. For us this year, the main topic is energy transition and equity. That's what we've been working on. As a part of that, we have done a couple of regional workshops, one in Imperial Valley and one in Kern County. And in a week's time, we are going to do one in Oxnard. So really looking at regional perspectives, we've been spending about 4 days at each of the locations to, one, do the workshop, but also engage with the communities, hear from the communities on what they think of the energy transition, what their needs are, and what the barriers are. And it has been very illuminating. So one thing that I wanted to summarize from our first workshop, regional workshop on this, is some of the comments that Dr. Emmanuel Pastor and Dr. Chris Benner presented in terms of, how do we center equity as a part of our conversation? How do we center our community engagement as a part of our work, but not really, sprinkle it at the end? So how do you make it foundational to the work we do? So one of the first things, they talked about is words matter. We really need to shift the framing of how we talk about the economy, the energy system, the environment, to say more of our economy, our energy system, and our environment. It really starts with that, making sure that we are working together for all of us at the same time. Two, timing matters. We need to create opportunities early and often for community stakeholders to engage meaningfully in the process. It really means soliciting, understanding their needs, constraints to make sure that they are a part of the conversation from the beginning of the FNE proceeding, not an afterthought or in the middle of it. And people matter. We need to be thoughtful about inviting, who to present and work closely with the array of stakeholders to make sure we're having a comprehensive set of, people at the table and the voices to really represent the diversity of our wonderful state. And this is an important one that I really took away, which is there will be conflict. To achieve equity, rather than, to achieve it, we just need to accept that there is going to be conflict. And rather than running away from the conflict and those difficult situations, we really need to learn and, do our best to lean into the conversation. Make sure we are having the conversation, even though it is difficult. And finally, the consistency and communication matters. Equity really relies on trust building. It's very, very important to build trust. So it's important to make sure we don't do this sporadically, make sure we're doing it consistently and in a transparent manner, and help build relationship, and also ensure that we are working with people that have trust in the communities as we move forward. These are some thoughts of wisdom that Dr. Pastor offered for us as we got into it, and I just wanted to share this here. I also want to just close by offering one additional perspective that I continue to hear as we go through this. We are in an amazing situation of transition in energy. It's an extraordinary moment where we are trying to contend with climate change, trying to contend with reliability, affordability, safety. It's important for us to make sure that we are also working on the equity piece and the environmental justice and racial justice as we move forward. So as we go through that, there is a very wide recognition amongst the agencies, our staff, the consciousness of people of California, that this is something that we want to work on. And I think that is amazing that we have that. But I think it's important for us to note that this work is not about just digging ourselves out of that hole of the inequities of the past. It is about centering the communities in the middle to frame the conversation of the future. So I just want to make sure we are not just focusing on fixing the past inequities, but really centering and respecting the values and the viewpoints of the communities as we move forward in framing our future. So with that, I'm looking forward to this conversation. Again, thankful to everybody who's attendance and the wonderful staff at CPUC, my colleagues at CEC. I want to just give a call out to Ben Finkler, Eric Lyon, David Earn, and Tom Flynn, obviously Lorenzo, who's going to speak today, for their extraordinary work at CEC, for helping teach me, for teaching me the value of equity, for helping me focus on that, their guidance, their work, and look forward to this conversation. Thank you. Back to you, Rob.
Great. Thank you, Vice Chair Gunda and Commissioner Houck. Is everything working okay for video and audio?
I think so. Can you hear me?
Yes.
Okay. Sorry, I had some issues getting online this morning, so apologize for being late. Okay.
And I'll turn it over to you.
Okay, thank you. So good morning, everyone. I want to thank you for joining us. And again, I had some technical errors this morning, so thank you for your patience. I'm Darcie Houck, the assigned commissioner for the what we're calling the high DER proceeding. And I'm pleased to be here to co-open today's hearing with Vice Chair Gunda from the California Energy Commission. We're going to be discussing several components from track 2 of this proceeding, which again, we refer to as the high DER proceeding, as well as upcoming efforts on our community engagement for tracks 1 and 2 of the proceeding. The overall purpose of this proceeding is to consider new and improved approaches to electric distribution planning and operations to accommodate the anticipated high growth of distributed energy resources in California. In today's workshop, Energy Division staff will be presenting an overview of the PUC's high DER proceeding before focusing on specific Track 2 items. And again, with us today, we have Vice Chair Gunda and his team from the California Energy Commission, who we are working collaboratively with, and they will be presenting an overview of the Energy Commission's informational proceeding on distributed energy resources and the existing and future collaborations across the two proceedings and between our two agencies. We'll then hear presentations from the investor-owned utilities on grid planning and operation. We'll hear from Dr. Lorenzo Christoph and our consultant team on potential distribution grid operation models, followed by Energy Division presenting the upcoming planned efforts on community engagement for tracks 1 and 2 of the proceeding. I want to note the importance of community engagement for what we're doing. We're really asking folks in the state of California to rethink how they use energy, what a high volume of distributed energy resources is going to mean, whether that is improved energy efficiency, rooftop solar, behind the meter storage, load flexibility, electric vehicles, and this is going to have to carry through to all of California. I appreciate and agree with the comments that Vice Chair Gunda made regarding equity issues. I think the PUC, in our San Joaquin Valley proceeding, did a really good job of reaching out and working with the community and set an example of what we can and should be doing to ensure that all of California is able to benefit from the energy transition that we're making. And DERs, particularly load flexibility and electric vehicles are going to be a huge part of that, and we have to make sure that we're working with everyone to achieve these goals. And so I would like to thank our Energy Division staff, specifically Simon Baker, Gabe Petlin, and Rob Peterson, for all of their continued leadership and hard work in looking at and envisioning how we're going to do community outreach and make this proceeding a success. And so the contributions of our staff are very valued. And with that, I just again want to thank everyone for being here today. I'm looking forward to a robust and meaningful discussion, and we'll turn this back over to Rob.
Great. Thank you, Commissioner Houck. I'll be sharing my slides, and next up will be Gabe Petlin, a supervisor of the Energy Division unit that oversees and supports the high DER proceeding.
Good morning. Thank you, Commissioner Houck and Commissioner Gunda, and thank you, Rob. Welcome, everyone, again. And I'm Gabe Petlin, and I'm in the Energy Division, supervising the grid planning, energy storage, and non-wires alternatives section that oversees this high DER proceeding. And it's my pleasure to begin presenting to you some overview slides of the context for this workshop and some of the high-level objectives. So let's get into that. Thank you. So starting with workshop goals, always great to be focused on what are the goals. And today's goals are really very focused. Number one is this workshop is intended to provide foundational education to stakeholders on distribution planning and distribution system operator topics that will support meaningful engagement and participation in the high DER proceeding. We recognize that whether you are a regular participant in CPUC proceedings or a newcomer, these are technical topics that we're talking about. And so in order to get everyone feeling comfortable and engaged in the future work that's coming up for this track, we're doing this education today. Second, we are going to present new and existing plans for community engagement for both proceedings track 1 and 2, and how CPUC is coordinating with CEC outreach efforts. And the reason why we are still not, well, it's fine, sorry. I'll try to cue you. The reason we say new and existing is because as early as when the scoping memo was issued almost a year ago, robust outreach was envisioned in this proceeding, and there is a plan that will be preview today, but we'll go into more detail in the fall when we have a workshop on it around some of the existing Track 1 community engagement activities. But today is also an opportunity to present a new and updated outreach plan for Track 2, which will be subject to comments after the workshop by August 31st. And so the first plan was envisioned from the beginning, and the second plan was responsive to feedback we got at the first distribution system operator workshop in May. So hopefully we've heard the feedback and we'll see what people think about that plan. Next slide, please. So some of the workshop objectives, and I won't go through each and every one, but we're intending to offer you a foundational understanding of how the California investor-owned utilities operate the grid and why we are considering alternative DSO models that we are investigating in Track 2, and what are some of the alternative models for grid operations that may be considered in the proceedings future grid study. So today's not the day to set any new policy. We're trying to lay down some vocabulary and some concepts to help everyone engage and participate in the road ahead. We will be presenting the draft outreach plan for the future grid study for feedback and discussion, and we will give you an updated overview of the high DR proceedings schedule and a preview of a fall workshop on community engagement needs assessment that is intended to determine what communities want and need from distribution planning. So we hope that you feel empowered to ask questions during and after the workshop, and that you are motivated to participate in upcoming listening sessions, and we will have information on how you can sign up to participate in those. And we hope that you will engage in future opportunities to provide both oral and written comments. Next, please. So anytime we talk about this proceeding, it's important to also put it in context of a larger action plan called the DER Action Plan 2.0, which was adopted by the CPUC at their April 21st, 2022 voting meeting. And what the DER Action Plan is really a 5-year roadmap from 2022 to 2026 for CPUC decision makers, staff, and stakeholders to facilitate forward-thinking DER policy. It's really about aligning the CPUC's vision with possible CPUC utility and stakeholder actions to ensure we have coordinated policy implementation related to grid planning, affordability, load flexibility, and market integration and customer programs. It's also intended to coordinate with the Environmental and Social Justice Action Plan, as well as our partner agencies CEC and CAISO. So the overall goal of that plan is to maximize the value of DERs on the electric IOU system to support affordable and equitable rates. It is not a way to determine the outcomes of individual proceedings. Those processes are ongoing. Next slide. So just to give you a sense of where today's workshop and the high DR proceeding fits into the overall overall DR action plan, it's really in Track 2 in grid infrastructure. So as you can see, we have 4 tracks, and I'm not going to go and present on each one, but just to give you a sense of how this proceeding fits in, it's in infrastructure, and in that track, the goal is to guide utility infrastructure planning and operations to maximize the value to ratepayers of DERs interconnected to the electric grid. So this gives you a little bit of context how today's workshop fits into a larger plan at the Commission. Next slide, please. So back to the high DER planning proceeding context, as Commissioner Houck said, the primary objective is to prepare the electric grid for a high distributed energy resource future by determining how to integrate millions of DERs within the distribution grid to maximize societal and ratepayer benefits from DERs while keeping grid reliable and rates affordable. And what do we mean by distributed energy resources? They are things such as solar, energy efficiency, battery storage, energy storage, electric vehicles, and demand response technologies. It also includes advanced time variant and real-time rates. Next slide, please. So just to clarify what we mean by a high DER future, the rulemaking is not saying that we are attempting to say, put our finger on the scale of what we think is the right amount of DER. We are agnostic as to the levels of DER adoption, but we recognize that it is a wave of increasing penetration that is going to happen, and we're not here to make it more or less. We're here to prepare for it, acknowledge it, and see what we can do to integrate it in the best way for the grid, either to maximize the benefits of the DRs or to minimize any unintended consequences. So just to clarify, when you hear us talk about the high DR future, this is not the, more DRs are better OIR. This is we know there's going to be a lot of DRs. How can we prepare the grid to best accommodate and integrate those DRs? Next slide, please. So the proceeding is organized into 3 tracks, and this is a refresher for those that are familiar and for those that are new. Today, we are mostly focused on track 2, but let me tell you first what track 1 is. It focuses on the distribution planning process and data improvements, and we are trying to improve distribution planning through a number of staff papers and workshops. We are also trying to quantify and understand the electrification impacts and potential mitigation to the grid from future electrification. And we are trying to improve our data portals where we share data that helps DERs and other communities identify where the best locations are for their goals and projects. And we are conducting a community engagement needs assessment to better understand what communities want and need from distribution planning. In track 2, in the focus of today, this is a longer-term investigation of distribution system operator roles and responsibilities that best accommodate the high DER future. So this is a longer-term vision and exploration of potential policy issues for how the grid operation roles might evolve over time. And it will lead to a future grid study that could inform a future decision at the Commission. And our third track is even more technical if DSO is not technical enough. In this track, we look at the role that advanced smart inverters can play in grid modernization. We have an active working group that is investigating different high priority use cases for how to leverage the capabilities of advanced smart inverters to provide value to DER owners and operators, to grid operators, as well as to value to ratepayers. So that will be resulting in another staff proposal and potential policy decision there. So this is a very busy, tracked proceeding. We appreciate everyone's engagement, and it's a strap on your seatbelts. It's going to be an interesting couple of years. We're already a year into it, and lots more to come. So with that, I'm going to pass the baton back to Rob, and I think we'll just be reminding folks throughout the day that if you have questions, raise your hand, and if you want to write your questions, put them in the Q&A, and the chat is just for logistics, not for any kind of substantive questions. So thanks again for participating, and I'll turn it back to Rob.
Great, thank you, Gabe. And I'll just cover 2 slides briefly and make sure we leave time for the Energy Commission to present. So again, Gabe talked about 2 different tracks, which are the focus of today. Both of the tracks in the high DER proceeding. Track 1 focused on distribution planning, and track 2 focused on distribution operations. There are 2 scoping questions in track 1 directly relevant to community engagement, and these have already been scoped into the proceeding, and there are plans to hopefully hire a future consulting team to initiate extensive community engagement. So the track 1, phase 1, which we're in now, asks what initial analysis is needed for the commission to determine in track 1, phase 2, which will start obviously after phase 1 of this proceeding, how best to improve local engagement in utility distribution planning. And track 1 will conclude with a proposed decision on near-term improvements for distribution planning, including on this community engagement plan. And then after that proposed decision is when phase 2 would start. In phase 2, the scoping question is leveraging the analysis from track 1, phase 1, are there ways in which utility distribution planning representatives could better engage with local and tribal governments, environmental and social justice communities, and local developers to ensure new planned loads and developments are factored into utility distribution planning processes and local concerns regarding distribution planning are adequately addressed. And hopefully that link to the scoping ruling works. There are several links to the scoping ruling in the slide deck, which are available again on the GridWorks site, which is in the chat. Now, track 2, which is the primary focus for today, has several two scoping questions. One of them is how do alternative distribution system operator DSO models compare in their ability to plan and operate a high DER grid, unlock economic opportunities for DERs to provide grid services, limit market power, reduce ratepayer costs, increase equity, support grid resilience, and meet state policy objectives. And the second scoping question, should the utilities be incentivized to cost effectively prepare for widespread DER, distributed energy resources deployments? If so, how? The primary deliverable for track 2 is a future grid study. And today we are presenting a new outreach plan to help ensure robust community engagement on future grid study development and review. I'll now turn it over to the Energy Commission. I'm going to stop sharing my slides. And Tom, I'm going to make you the presenter so you can share your slides.
Okay, thank you, Rob.
Okay, Tom, you should see that change shortly.
Yep, I think I'm there. See the slides?
We do.
Okay. Thank you, Rob, for welcoming us to join you today in this DER workshop. And appreciate Gabe going first and talking through and followed by you, Rob, and going through the PUC's DER proceeding because we really do, I think, collectively view these as complementary proceedings. Think they fit together pretty well. And there are certainly opportunities for both proceedings to collaborate, for both agencies to collaborate through their respective DER's proceedings, especially on community engagement. Really want to note that area. But first, I'll just say again, my name is R.M. Tom Flynn. I'm a senior electrical engineer in the Energy Commission's Energy Assessments Division, and I support the CEC's order instituting investigation on DER in California's energy future. And I've included the new docket number for this proceeding on this title slide. And then I have a slide at the end that includes a link when these slides are distributed. It includes a link for stakeholders and parties to get to that proceeding on our website a little more easily. Let's see if I can make this advance. There we go. So a bit of an overview on the CEC's DER proceeding. We're really, at the highest level, we're really focused on maximizing the potential of DER. And a similar theme is what I heard on the PUC's proceeding. Want to listed five areas that I really want to highlight with regard to the CEC's DER proceeding. The first one is that it recognizes that community engagement is foundational. And I really want to echo the points that the Energy Commission's Vice Chair Gunda made in his opening remarks, and really think those are worth repeating and have a slide on those. Our proceeding, secondly, explores policy options to grow DER. Third, we want to develop a means for producing DER growth scenarios that can be used in planning studies. Fourth, it supports investments in reliability, and there I'm referencing the Strategic Reliability Reserve that was created through Assembly Bill 205. And then lastly, for those of you who have been participating in the ongoing working group on supply side demand response that the CEC has been leading for over a year now, we're incorporating that under the umbrella of this proceeding as well. Obviously, demand response is an example of DER, so we think it would serve us well to roll that effort into this proceeding. So again, really think it's worth highlighting the really important points that Vice Chair Gunda made on community engagement. We really, in this proceeding, we really do view that quite strongly as foundational. And as Vice Chair Gunda mentioned, through our IPER process at the CEC this year, through workshops that have been held in different regions throughout the state, something that we've really learned are these points that I would like to just repeat again here. That words matter. It's not. It's a collective we. It's an our in terms of the economy, the energy system, the environment. Framing it that way, we think, is really important. It's something that we're working for all of us. It's a collective effort here. Timing matters, people matter. Building trust is very important in working with our partners at the local and community level. And consistency and communication matters. We're really trying to break down some silos, build lots of good, strong and trusting relationships as we work to really emphasize community engagement as we look to, and examine DER, distributed energy resources in California's energy future. So the second point I had mentioned at the beginning in terms of an overview is we want to explore policy options through this proceeding to grow DER. And one of the first things we want to do there is describe and quantify the full range of DER benefits. There are certainly benefits of DER that are recognized today, but we believe there may be benefits, potential benefits of DER that are not well recognized. And so we really want to kind of holistically capture the full range of potential benefits that DER brings to address decarbonization, reliability, cost effectiveness, and local benefits, societal benefits, non-energy benefits, such as resilience, jobs, pollution reduction, health issues. Those are all things that we want to capture beyond the traditional benefits that may be recognized up to this point. We want to make sure we capture them all. And we also want to estimate quantify the potential growth of DERs based on assessment of needs, and really want to emphasize needs at the local household and community levels so that we can estimate the magnitude of DER adoption and deployment that would be needed to fully realize the range of benefits that we hope to describe and quantify. And then lastly, the second sub-bullet there at the bottom, through this proceeding, through this informational proceeding, we want to take a look at policies, programs, funding, incentives that could be suggested and recommended to help maximize the potential of DER that we would be identifying through describing and quantifying through this proceeding. And then earlier I had also mentioned DER growth scenarios. So a second big piece of this proceeding at the CEC is we want to develop a methodology for formulating DER growth scenarios. We want, through this proceeding, we want to work with stakeholders to develop such a methodology and use what we learned through identifying benefits and needs as input into that methodology that we would develop for DER growth scenarios, vet and develop some actual scenarios, do some test runs, vet those through public workshops in our proceeding, and come up with, hopefully come up with a final set of DER growth scenarios that could be used in planning studies. And so that takes us to the second main point here, which is the intention is to use the DER growth scenarios developed through this proceeding and plug those in through planning studies. For example, the continuing work that we'll be doing under SB 100 and apply those scenarios in those studies to estimate the contribution that DER can make towards our climate and energy goals, such as, in terms of the grid, optimizing, as Vice Chair Gunda mentioned earlier, really want to optimize between the bulk level and the distribution level, and really take a closer look at the role that DER could play in meeting those needs, through increased DER deployment. One of the potential benefits is reduced land use impacts. We also want to flatten the duck curve, obviously. And then there's the societal and non-energy benefits, decarbonization, real resilience, local air quality impacts, meeting local and community needs. I also had mentioned at the beginning that through this proceeding, we are supporting investments in reliability. So one of these demand side grid support that some of you probably are familiar with is intended to incentivize distributed energy assets that would serve as on-call emergency supply and load during extreme events. And then the distributed electricity backup assets will incentivize deployment of zero or low emission technologies such as fuel cells and energy storage. And then the last point I'd mentioned at the beginning in the overview of this proceeding is we are incorporating the ongoing work that the CEC has been leading to improve the methodology for determining the load reduction impacts of supply side demand response that participates in the California ISO market. We initially had began this effort a little over a year ago in response to a PUC decision in their RA proceeding, their resource adequacy proceeding. And earlier this year, through the stakeholder working group that we led through most of last year, we put together a report and provided that to the PUC in February of this year. And that provided our interim findings and recommendations based on working with stakeholders through that working group. We've been continuing to meet with stakeholders in that working group process. At times we meet every other week, quite often, and we will be wrapping up this effort towards the end of this year with our final recommendations, and that's really aimed towards resource adequacy year 2025 and beyond, and we'll provide that report to the PUC early next year. And when these slides are distributed, you can't actually see the URL here, but the URL, but I've included a link here that will make it easier for stakeholders and parties to go to our proceeding And you'll find there a means by which you could submit comments. There's an email that you can use to contact us with the staff at the Energy Commission working and supporting this proceeding. So really want to just wrap up by summarizing the 5 points again, that our proceeding is focused on maximizing the potential of DER. It recognizes that community engagement is foundational. It will explore policy options to grow DER. It will develop DER growth scenarios to use in planning studies. It supports investments in reliability, and it also integrates the work that we've been doing on supply side demand response. So with that, I will see if there are any questions.
Thank you, Tom. I see a few questions in chat in the Q&A, and I'll try to respond to them to the extent I can. First question is from Richard Coe, and I'm just going to share a slide that Gabe shared. It's slide 13. To make myself the presenter again. But I think generally, for the purposes of this proceeding, Richard, that this OIR is neutral on the number of DERs to be planned, on setting policy regarding the overall number of DERs. And I think hopefully you can see this slide. But for the CEC, Tom, can you see that Q&A? The question is regarding.
I can't actually see it.
You can't see it?
Maybe for the benefit of the audience, we can just read out the question just to help it.
Yeah. I just lock when I share my screen, I lose that.
I can read it out. So you've got screen. I'll do Q&A. All right. So Richard Coe from Public Advocates, and if people can say where they're from, it helps us understand, who's participating. But his question is it correct that there is a key difference between the CPUC and CEC proceedings? The CEC proceeding is seeking to grow DER, whereas the CPUC is neutral on how much DER is needed. If so, how does that affect the way CPUC and CEC will work together? That's a great question. I mean, as Rob said, we stated that the purpose of our proceeding does not seek to set a higher or lower quantity of DERs. It recognizes that numerous policies, cost reductions, consumer adoption, and just an awareness amongst consumers that this is a growing wave and it's going to increase, but that we do need to prepare for it and make sure that the benefits are maximized as well as the unintended consequences are minimized. But Tom, what are your thoughts about this interesting question?
Yeah, I definitely don't see that as a difference between the proceedings, but instead, really, my perspective is I see that more as one of the complementary dimensions of the two proceedings. And I think similarly, I don't believe that we are looking to set policy on any particular level of DER that should be achieved. We're really just trying to explore the benefits and levels of DER that could help California achieve those benefits and lay that information out there for others to consider. But I definitely don't see us either trying to dictate a particular level of DER that should be achieved, but just it's an informational proceeding. Try to generate that information to put it out there for consideration.
So let's go ahead and move forward into the education components. There are a couple other Q&A questions, and I will seek to answer those in writing. So if Quinn, I believe Quinn, if you're ready, I will make you the presenter. Quinn Nakayama from PD.
Very cool. Well, thank you so much for having us all here today. Rob Peterson, Gabe Hetland, really appreciate this opportunity to come by. We have some fantastic comments being here, fantastic comments and content that we have here to present for you today. Just wanted to do a quick introduction. My name is Quinn Nakayama. I'm the director for an organization called Integrated Grid Planning and Innovations here at Pacific Gas and Electric Company. I also used to run the distribution control centers for a couple of years here at PG&E over in our distribution control center located in Concord. So today we would love to have the opportunity and the honor and the opportunity to kind of present to all of you about how does this actually work? You know, we have these control centers and we talk about what it takes to operate the grid, but what does that even mean? You know, and I'm noticing that there are 222 people on this call from various walks of life. And fortunately, it's not one of these type of workshops where it's like 95% utility and CEC people. I'm noticing there are such a variety of people that are here on the call that are interested in learning about what we do as a grid operator. And the most powerful piece of this is how do we get all of us informed about what happens underneath those four walls so that we can figure out what is the best approach to where do we go in the future. There's going to be a lot of conversation here in California around the distribution system operator, the distribution market operator. What does this all look like? How do we get this to the future of a highly distributed network of solar, energy storage, EVs? I mean, I see on the call right now, you got folks like Stellantis, Nissan also on this call. But also being able to meet the needs of our cities and counties. I see San Luis Obispo on this call, Santa Barbara, and also meeting the needs of all of our communities, the disadvantaged communities, the urban communities, the commercial communities, the industrial communities. How do we create a grid that meets the needs for everybody, equitably, reliably, safe, and clean? These are all things that we need to factor in as we move into the future of the grid. The grid is changing, and we have to be able to adapt to those changes. But before we can figure out where we want to go, it's really important for us to be able to figure out where are we today and how do we operate the grid. Our desire is to try to make this not as dry as possible, and I can geek out on this for hours on end. But to be able to present this in a way that is really consumable to everybody on this call. We can get really engineering focused. We can geek out on switches and line reclosers and substations and circuit breakers. But to be able to help understand this, we're going to have to use maybe a lot of analogies as we think about how we take a look at our distribution grid. How do we operate that on a day-to-day basis? It's not something that just operates itself. And then how do we figure out from there, where do we go from here? And today is just a real honor to be able to present this to you in a way that hopefully allows you to have a greater appreciation and knowledge about what happens underneath the four walls of the distribution control center. So toward that, I'm going to go ahead and share some slides, and hopefully you can see this, barring any type of major technical difficulties. And I'm just going to confirm, can you all see my screen? I'm going to hope that's a yes.
I can see it, Quinn.
Fantastic. Thank you. I appreciate that. So what are we going to present to you today is really our objectives here are really just educational. You know, we don't really want to talk about policy advocacy here on the call, but really just to talk about what are some of the foundational functions and operations of a distribution grid operator here in California, and really enable stakeholders, all of you, to understand the basic of this grid operation so that we can really engage in the conversation regarding the high DER OIR on the track 2 on the various models that Lorenzo will be so gracious to present to us later on today. In order to do that, we're going to do some introductions on the physical grid. What is the physical grid? How does energy get from point A to point B? We're also going to go into the distribution operations in depth, what happens underneath the four walls on a day-to-day basis in the control centers as we look to operate the grid to create a really flexible and safe and reliable system. What are some of the external factors impacting operations today? And looking to the future, what are some of those challenges, but what are some of those opportunities? And the speakers prior to us really kind of nailed it home. Listen, We are getting to a much more distributed energy future. Technology is making leaps and bounds changes on how we interact with energy. And so that's creating this beautiful ecosystem of both centralized generation and distributed generation. We have to figure out how to make those blend together while still being able to operate the system. I have two of my colleagues here today, Marcus Guerra and Dan Bedell, who would like to see if they can go ahead and take this moment to kind of introduce themselves and talk a little bit about what their roles are and what they'll be presenting. So with that, why don't we go ahead and start with Mark? Do you want to say a quick hello to everybody?
Hi, good morning. Hello. Thank you for having me. Marcus Guerra. I'm the director at Southern California Edison, responsible for distribution system planning and strategy. And actually, I would be remiss if I didn't also introduce my co-pilot in this discussion, Tony Edelson, if you'll come online. He's our director of our grid operations.
Thanks, Mark. This is Tony Edison. I'm Director of Grid Operations here at Southern California Edison. I'm going to help come present with Mark.
And we have Dan Bedell. Dan, can you go ahead and quickly come on screen and introduce yourself?
Morning, ladies and gentlemen. Dan Bedell. I'm a distribution and operations team lead here over at San Diego Gas and Electric. I supervise the DSOs and a group of engineers here in the control center. I've been in operations since 2009, spending most of my time here as a system operator. And like Quinn said, I'll be sharing with you a brief introduction to the grid, how we get power, and both the size and scale and complexity of the distribution system.
A very cool thing about Dan is while I sit in my 4th bedroom office / conversion of that we have in the COVID era, I think Dan behind you is the distribution control center. Is that correct?
That is correct.
Very cool. So you guys get to see a little bit of a glimpse into what that looks like behind him as they look to operate the grid right behind him. So that's super cool. Well, with that, we're going to go ahead and dive right into this. And so I'm going to go ahead and kick this back over to you, Dan, and talk a little bit about the introduction to the physical grid. And I believe you're going to be taking this away.
Yeah, thank you, Quinn. And pleasure to present for you today, everybody on the line. Like to just talk briefly about the physical grid. So like Quinn alluded to before, this is a high-level educational slides from all the IOUs. I'm going to talk to you basically as if you don't understand a little what it takes from getting from the power plant to the customer. When we flip on a light switch, we don't really know the ins and outs. I know for sure before I came to the control center, I didn't know anything about. I just relied on that power. Anytime I flipped that switch, power would be there. So like mentioned before, this is a brief overview of power plant to customer, how the power is generated, transmitted, and distributed to us. So when we say Alexa light on, the power comes on. So I hope I didn't turn on anybody's lights. If not, you can just go and mute me. So having access to power is something we all take for granted. We don't realize that until we're hit with an unplanned outage. Sitting there, typing away on our computers, and then the screens go dark. I've been in this control center here when we lost power to all of San Diego County. So I know what it is to be on that side of the house also. So how does power end up at our house? You can see from this basic diagram here, we have a generator station in the bottom left-hand corner, and right outside that is switchyard. So generators are massive machines that run on different types of fuel, and through that, there's a transfer of energy that creates electricity. That electricity is harnessed and pushed through cables and wires just outside that generation station to a switchyard. Through that switchyard, it goes through the first transformation process, which is our step-up transformer. This step-up transformer boosts the voltage from the generator to a transmission level voltage, which can range from 120 kV all the way up to 500 kV. This large and massive amount of power enables us to transmit this bulk energy from the generation stations all the way to onto the the transmission lines through the transmission system. So this bulk power gets carried through the high voltage lines long distances because generation centers are usually not stationed close to residential or commercial areas. So once it reaches the first transmission substation, that's when we start bucking the voltage down a little bit more. We get to the main bulk transmission system. From this, it gets bucked down to around 60 kV or 115 kV, which is a more manageable voltage for the transmission side of the house. And it continues on its path, continues on its way towards the customers. If you want to click through, Quint, I think there's more in it. Yeah, there we go. So 60 kV to 115 kV lines go more inward into our service territories, into our residential and commercial hubs, into our distribution centers. So once it hits our distribution substations, the power is transformed into a lower voltage, which is our distribution voltage. So that distribution voltage can range anywhere from 34 kV all the way down to 4 kV. But inside those distribution substations, the power is dispersed evenly throughout it, through feeders or our circuits. And that's carried down distribution lines, either overhead or underground, depending on where you're living, to your house, to your neighborhood, to the last step of the process, where it comes to our distribution transformers, which are right outside your house. These could be overhead on pole tops or underground in green boxes or encased enclosures. And this is the final process where it's transformed into usable utility voltage. This voltage can range from 120 volts to all the way to 240, depending on the needs of the customer. So now the transmission and distribution system is not as linear as this drawing. And I'll go into more slides describing the bulk power system and also the distribution system. Quinn, next slide. So here is a representation of the transmission system or the bulk power system. And just fair warning, I'm not a transmission system operator by trade. I'm a former DSO, but I know something about transmission systems. So transmission systems rely on a mesh network. This mesh network or loop configuration allows for multiple pathways for energy to flow across the grid. These multiple pathways also allow the bulk transmission system the ability to remain reliable and stable. And it also connects other utilities via interconnections and different components throughout the state and through our regional network. But the bulk system is not entirely operated in a vacuum. There's key players that have their role as well, such as FERC, Federal Energy Regulatory Commission. This is an independent commission or agency that regulates the interstate transmission of electric, natural gas, and oil. FERC helps regulate the transmission and the wholesale of electricity through the interstate connections. They create and also enforce reliability standards. Next, we have NERC. NERC's the North American Reliability Corporation. They work with all the stakeholders to develop strategies for standardizing operations. They monitor and enforce compliance. And when we're hit with blackouts or major disturbances, they're point on doing a thorough analysis and investigation of those circumstances. Within NERC, it's broken down to regional entities. There's some on the East Coast, there's some in the South. California is part of the WEC, which is the Western Energy Coordinating Council. And then within California, there's the California Independent System Operator. They manage the bulk system for the IOUs. But the physical operation of this transmission system, it is given to the owners of those transmission systems, which are the utilities. Next slide, please. Now here's a simple representation of a local distribution grid. It doesn't look like this in real life. It's not just squiggly little lines in a circle. There's a lot of intricacy with this. But this is the simplistic view of a single circuit. You can see it generates from the substation and it goes out towards the customers. This is what we call a radial system. And it allows for the single path flow to multiple customers along this path. The radial feed of a distribution system has multiple points along the way that allow for isolation and restoration. But I'm going to save that topic for Quinn, who will go in more in depth on that later. Although most of the distribution system is run in a radial configuration, there are some that are in a loop configuration, which provide more reliability. And these are usually in urban centers. Like the transmission system, distribution system has its own governing body, which is CPUC. They help regulate the utility in multiple aspects, such as funding operations, approving infrastructure investments, and ensuring the safe operation of the distribution system. But the distribution system solely operated and managed by the utility's DSOs. Next slide. And here we see the totality of the distribution and transmission system. So in review, we can see the hierarchy of this system. The mesh transmission network connects generation to the transmission system and also provides connections to others within the WEC. This mesh configuration provides reliability and stability of the grid and also allows for multiple paths to be taken out of service without interruption. Now, every utility is different, but utilities usually have set jurisdictional boundaries that demarcate the transmission side from the distribution side. These interface points require constant communication and coordination when operating these equipment, and also in emergencies such as blackout or load curtailment. The physical topology of the transmission distribution system is kind of analogous to the circulatory system. Transmission systems, the large arteries pumping the blood to and throughout the body, which you can consider as the grid, to various locations where it's transformed into, it travels into the veins to the extremities of the system. Next slide, Quinn. All right, so I'm not an operator up in the Fresno area, but I can kind of see the depiction here. This slide has various purple and green lines on it. This represents the transmission system in the area of Fresno. You can see the little triangles on that. That represents either transmission substations or distribution substations. Like discussed before, the mesh network of this transmission system allows for energy to flow from the generators to our distribution substations. These pathways these paths can have multiple routes that allow power to flow uninterrupted. And there's also large numbers of interconnections with neighboring utilities and other entities. Next slide, Quinn. Now, we see that same area. Now it's inundated with the distribution circuitry. It's a little bit more congested, don't you think? So this congestion of the distribution system, it requires 24/7, 365-day a year management by distribution operators. With planned maintenance, repairs happening daily, this requires multiple reconfigurations on the circuit to isolate equipment and allow for the safe repair of equipment by those crews. A DSO might have multiple jobs, multiple parallels, multiple outages going in the same day, as well as trouble work, which is unplanned work, such as car contacts, de-energizing for safety. This all adds to the complexity of the distribution operator and the distribution system. Next slide, Quinn. Now, everybody recognizes our lovely state of California here. And this is our service territories of 3 IOUs presenting today. We have PG&E up in the north. Their territory spans from San Ynez all the way up the coast to almost the Oregon border. From San Francisco all the way to Sierra Nevadas. So SoCal Edison, our neighbor to the north. They're from Orange County all the way up to Santa Barbara, Goleta to the border of Nevada and Arizona. Then you have SDG&E, my utility. Going from the border of Mexico all the way up to Dana Point, from the beaches of Torrey Pines to the mountains just before Imperial County. The service territory of these, all 3 IOUs are as diverse as its customers. From the beaches to the mountains to the deserts, the urban centers to the rural towns. From heavily commercialized areas to the agricultural load. All these pose different challenges and different needs. The way an operator would operate in an urban environment is totally different from the rules and regulations and what we do when those wires cross into rural and mountain districts. Next slide, Quinn. Now, on this slide, you can see the breakdown of all 3 of the investor-owned utilities in the state of California that are presenting today. And it breaks down both the assets and the operations for both the transmission and distribution operations. And right off the bat, you can see the overwhelming number and the magnitude of assets, both planned and unplanned work that goes on the distribution system. Now you can see this magnitude requires constant monitoring and constant management by DSOs. With the transmission system being looped and meshed and construction standards helps prevent unplanned outages. But when we get into the radial feed of the distribution system and the distribution circuits, the proximity for this equipment and the lines to roadways and customers attribute for the large number of unplanned outages. So in summary, the management and operation of this distribution system not only requires 24/7, 365 days monitoring and executing of switching by DSOs. It also requires an army of skilled individuals to maintain, install, and repair the equipment on the system. The management, tracking, and protection of the crews is a major responsibility for the DSO. So having situational awareness as well as the controllability of the system keeps those crews and the public safe. I appreciate your time and I hope you learned a little bit today. And I want to kick it back off to Quinn, where he's going to be talking about distribution operations and what it takes to be a DSO.
I think we were going to take a quick pause here. Matt, I believe we were going to see if we can entertain any type of questions today.
Yeah, that's great. Dan, thanks very much for your presentation. Good morning, everyone. Matthew Tisdale with GridWorks, supporting the facilitation of the workshop. I have a couple great questions coming in from the Q&A here, so I'm going to share those with you, Dan. First question we'll take up here from Cal Advocates. Is each local distribution area always connected at a single T&D node? Or are there some situations in which a single local distribution area might connect via multiple T&D nodes? If some have multiple T&D nodes, approximately how frequent is that?
Multiple T&D nodes. You're talking about distribution substations connected to the transmission?
I believe so, yeah, T&D node substation, yeah.
So for the most part, yes, a lot of distribution substations have multiple routes through our transmission system, allowing for seamless de-energization of transmission lines with keeping the distribution still energized. There are some that are just tapped radial transmission feeds, but those are usually delegated to customer-owned equipment.
Okay, great. And another question here from Scott Enders. Scott says, I have heard that each IOU has differently configured systems. For wildfire risk mitigation, SDG&E has the ability to more surgically shut off segments. Let's see, sorry, the field keeps moving. The question is this true that some utilities can shut off circuits differently than others due to the configuration? And if so, could you explain?
Yeah, so I don't want to speak for PG&E or SoCal Edison, but here at San Diego Gas and Electric, we take wildfire mitigation serious. We have a large department that goes into analyzing and investing time in reconfiguring circuits to prevent de-energization during those times of the year by strategically undergrounding cables, providing alternative sources of energy for those customers. And we also install massive amounts of SCADA devices so we can surgically de-energize, so we're not taking out the entirety of the circuits.
Maybe if you want, I can go ahead and echo a little bit. I believe that traditionally most of the IOUs at Southern California Edison, San Diego PG&E generally have similar sort of technologies that exist on their circuits that really enable them to de-energize just certain sections of the distribution grid. The real question and the differences may arise in how many and where they're located. As well as what percentage of their distribution system is in high fire threat. Up here at PG&E, about 50% of our service territory is in high fire threat. And we look on our wildfire mitigation plans to place sectionalizing devices, which are basically devices that allow for that disconnect to occur from the general grid, that are right on the border of many of our high fire threat district borders. And so I would say that Southern California Edison, San Diego Gas probably have the similar or same approaches on where they put these type of devices to be able to make sure that we're really targeting places for de-energization in terms of, for example, public safety power shutoff. It just sometimes depends on how many line miles exist in those high fire threat districts. That could be a difference between the three IOUs.
Great, thanks.
Good. And we also have a large extent of weather stations that we connect close to where we're going to be de-energizing. So we have a granular detail of the fire threats in those areas, and we make our decisions based on that.
Great, thank you. And one more general question at a 101 level here. And I want to note that there's some other questions here that ask for the utility's opinions about things. And we'll give you a chance to respond to that in the Q&A if you like, or we can come back to them after the workshop. But keeping some of the 101 questions in focus here, how much does California rely on its bulk transmission system? And what challenges will come up as we make the transition to a system that depends on local, especially customer power that is two-way rather than one-way?
Now, I'm not really too familiar on the transmission system, but there's a great deal of resiliency on the transmission system, and we do rely on the transmission system a lot. In the future, there's going to be a lot of transition from that resiliency and that reliability on the transmission system, putting the onus on the distribution system. Distribution system is going to be, in the future, it's going to be the spearhead, I believe. But
Matt, we can talk a little bit about some of those questions. I think it'll be addressed, especially as we look at what it takes to operate the distribution system and what type of impacts it will have when you have more and more generation resources or energy storage resources at the more distribution side. I think the biggest thing that we can take away on a diagram like this is if you have a generation station that's located somewhere on the transmission system, you'll see multiple pathways where that energy can go. It can go left, it can go right, it can go up, or it can go down. And depending upon, where lines you need to take out, that generation technology still has the ability to access this transmission network from multiple pathways. On the distribution system, and we'll talk a little bit about this as we go through kind of the more granular levels on the distribution system, it's kind of a one-way path. And so if you were to have something occur on a radial line and the distributed energy resource was located on this radial line, it would have a hard time getting back toward the sources to be able to feed back into the grid. So, we'll get back maybe a little bit more into this as we get into the slides on on distribution system operations, as we look at how we operate the system. That can maybe shine some light on that.
Okay, great. We use the time. Oh, go ahead, Mark.
Matthew, just on the question on the bulk transmission, absolutely, that's got to be part of our overall question with the many changes that are happening with the climate and others. I think you're going to want to have a super reliable system that does rely on having a very robust transmission system to meet some of those growing demands. With extreme heat, some of the cold spells and others. We're going to need energy from all sources, not only generated from locally from within, but also from outside other areas. That as events may come up, we will be dependent on having additional transmission resources brought in. So just wanted to add that in.
Okay, great. Thanks, Mark.
There's
All right,
one more question that I thought be worth highlighting, and not sure if you want to take it right now or incorporate it into your next segment, but it's from Scott Anders, and he says that California has relatively low load factors, roughly 50%, meaning the average load is about half of the peak load. This means that a lot of grid capacity is unused most of the time. Is it possible to manage DRs to fill up this unused capacity? Is there a downside to this, like thermal issues? Does the grid need some unused capacity to maintain thermal balance? So I guess first off, do you agree with this statement about the low load factors? And what are your thoughts? And again, if it's coming up in a future slide, you can bring it up then. But I thought it was an interesting question.
Mark, why don't we turn that question over to you? That might be a good one for you to answer.
I'm trying to digest the question there a bit there. So basically kind of what I know here is like, having better load factors is really what's kind of informing our overall rate design on better utilization. Some things to consider is that not all loads are that flexible on the system there. It's definitely things that from an asset management perspective, we want to understand how that's impacting not only our assets from a capacity usage perspective, but also from a utilization of the asset on is the equipment being run harder or more often than it should be, leading to a more increased rate of replacement of assets. So just kind of reacting to the question, that's some of the initial thoughts that I have.
I would also stipulate that, in terms of like 50% loading factor to what the actual system is capable of is really dependent. I mean, I don't know if that 50% is true or not, or where that number may have came from, but it is very local. There are places where you're at 98% capacity factor. There are going to be places where you might be 25% capacity factor, right? And so each one of those local, really hyper local areas will dictate how much is maybe available for further load and capabilities in those particular areas. Taking a look at the system and saying on a painted brush, is 50%. Can we load up more DERs? Are there more opportunities? Really just depends on the hyperlocal, what you would consider thermal constraints on how much energy that it can either absorb or push back into the grid. And each one is dependent. I will say that load looks very different in various areas. You got the coastal communities, a lot of fog coming in. Solar drops off when that fog comes in during those summer times of July. If you've ever been to San Francisco, you get a lot of fog come rolling into that area. In the valleys, you got a lot of space, right, to be able to have a lot of solar. But again, not a lot of residential in this area. In the mountaintops, you have a lot of wood, a lot of forested areas, makes it very difficult to maybe bring in a big solar farm in some of the mountainous and the heavily trees areas, and all of that contributes to different type of load profiles that we see. We'll get to kind of like what that might look like maybe later on in the slides, but I would say that, you know, maybe there might be opportunities to place more DERs and more generation and even increase the amount of load for transportation electrification, but in a lot of areas, no. And so it really just depends on the location.
Okay, great. That's the time we had allotted for this Q&A break. We'll stop in about another 15 minutes for another one. So thanks for keeping the questions coming, everyone.
Fantastic. Well, I think I have the next share stuff, so I'm going to try to keep this as light as possible, as it can get pretty heavy into the details about how we operate our system. So we'll try to keep this light. I do apologize. I am a little bit tired today, as Top Gun Maverick came out as a downloadable movie for me last night, and you know, it's a beautiful movie from my 80s and childhood that I had to now watch it like the 7th time, so I'm a little bit tired today, but try to keep this a little bit light. You know, we really want to allow you to explain what happens in the distribution control center. Really give you a grounding on what it takes to operate our grid. You know, I'm a geek, so like for me, being able to hear the air traffic controllers, like sometimes you're on a Southwest flight, or I think it might be United, you can go to channel 11 and hear the traffic control operators over on the flight control, being able to talk to other planes and how it operates. I kind of geek out on that. It's kind of what I do when I'm on a plane that enables that type of function. And so, you know, for me to be able to talk to you about what happens in the control centers, similar to maybe what happens in a flight control center, is totally cool. But to do this in a way that doesn't lose the audience and have that, you know, gloss come over your eyes as we geek out on major engineering components is going to be a balance that we try to strike as we talk about what happens in the control centers. I will do my very best to try to talk about these terms in ways that are not utility speak, but we'll have to introduce some terminology as we kind of go through what it takes to operate the grid. So what do we do in the distribution system operators? And first off, I want to give a big shout out to the operators and the operational engineers who sit 24/7, 365. Their butts are in the chairs, in computer screens, talking to crews, working with engineers, working with the various people out there in the field to be able to make this grid reliable and safe for everybody. The IBEW operators and our fellow unions, as well as our ESC engineers, work so close and hand in hand, and they are the true heroes on our distribution grid. It doesn't matter if it's Thanksgiving, it doesn't matter if it's Christmas, it doesn't matter if it's Labor Day. Somebody has to operate the grid, and they have to be able to do so to make sure that we can all enjoy power 24/7, 365 in the most reliable way possible. They do this by doing two things. One of them is we have planned work out there. I have to replace a pole. I have to replace, you know, maybe some wires and conductors and cables out there. I might have to replace equipment out there. And for those of you who have done some work on your electrical inside your home, you know what it takes to sometimes do that electrical work. You have to either shut down your entire home. I've had to do that before. You've had to, if you're replacing, like, let's say, a light switch in your kitchen, you have to flip off that breaker in the kitchen and de-energize your entire kitchen. And it's a little bit similar on the distribution grid. In order to do work on our distribution grid, we have to sometimes turn off portions of the distribution grid. Now, fortunately, we don't need to turn off the entire kitchen. We don't need to turn off the entire house. We have the ability to kind of reroute electricity. We'll talk a little bit about that. So only maybe the plug that you're working on is the one that is de-energized, while the rest of the kitchen remains energized. And that creates the least amount of disruption for our customers. Typically what we have is you have a single circuit. That could contain 4,000 customers on that single circuit. Anytime we did work, it would be very inconvenient for all 4,000 customers if all 4,000 customers had to be de-energized during that period of time for us to replace one pole for an 8 to 10 hour period. And the ability to be able to move customers around on the distribution system is what allows us to maybe only de-energize 8 customers for that period of time, while the rest of the 3,992 customers on that circuit remain in power. And so these operators have to create and direct some of these plans out there to make sure that they can move load around appropriately, move customers from circuit to circuit in a way that doesn't disrupt, for example, your voltage that you have, which could cause problems on your computers, your refrigerator, your washer and dryer, to maintain all of that voltage in a level that your appliances can then use. It has to be done in a very stepped fashion that enables you to maintain that type of reliability when we do planned work. We also direct emergency switching. What does that mean? Well, we have problems that happen on the distribution. You saw the sheer number of line miles that we have on the distribution system. We have things that happen all the time on that distribution grid. 2 o'clock in the morning, an individual might accidentally hit one of our poles and cause a major outage to occur in our system. That then de-energizes 2,000 customers, 4,000 customers, 350 customers. And our operators are working at that moment to try to figure out how do we take all that energy and move it to different locations so that people can get end power as quickly as possible. We also support major large storm responses, major events. For example, the Warriors, go Warriors. I'm a PG&E guy, so of course we had the NBA Finals that occurred here in our local town, and being able to have a hyper focus on making sure that our customers and the entire nation and the entire world can enjoy that game without having any type of major energy disruptions during those major events. Earthquakes. How do we go? California is a major earthquake zone up and down the entire California service territory. How do we make sure that we are restoring customers as fast as possible if an earthquake disruption happens? Solar eclipse. You wouldn't believe this, but while I was at the control center, we had a major solar eclipse that occurred, and questions started to rise like, we're going to lose a lot of solar on the system. Are there going to be any type of voltage problems that happen on our system? Do we need to move load around in case any of that occurs? And taking a look at the system to make sure that everybody can enjoy power during those periods of times as well without any type of disruptions. Atmospheric river events, wildfires, these are all major things that these control centers respond to and support to make sure that all electrons are being delivered to all of our customers as quickly and fast as possible if there are any disruptions. We monitor the distribution grid for any type of real-time issues like power quality, make sure that your voltages are at the right level, frequency is looking good, so that you can enjoy your appliances that require that type of level of tolerance. And anytime it goes outside of the tolerance, bad things happen to these type of appliances, and we want to make sure that we're providing that power quality so that you can enjoy your refrigeration. Commercial entities can operate their data centers. Industrial entities can run their machines. We also need to coordinate with the transmission centers where they're separate. Some folks do it together. And there's a lot of coordination between planning and operations that happens. A lot of conversations that happen. Oh, we got this bad reliability. This thing happens. These customers get de-energized all the time. What can you do on planning to be able to help us out? What can we do to be able to focus some efforts and investments in those areas to be able to make reliability better, to make safety better for our customers on the grid? And there's a lot of interplay between our planning folk and our operations folk to be able to make that happen. As with operations, we see things that happen real time and can inform planning about how exactly to best make investments on the system. I won't go too much into this, but this goes to show you just the number of people that are involved to make this all happen. A system operator sits at a desk with multiple screens looking at multiple related applications, but they're also on the phone. They're talking to their operational engineers. They're talking to a troubleman out there in the field who can actually pull physical switchgear to be able to disconnect people from the grid. They're talking to substation electricians to be able to maybe perform specific activities that need to happen at a substation. They're talking to construction crews who are going to be doing some of the major construction related work or major repair work. Hey, how's it going? When are you going to be done? Is this going to be able to be restored by the time you say that it's going to be? I'm showing an estimated time of restoration at 2 p.m. Our customers expect energy at 2 p.m. Are you going to have the system restored so that I can go ahead and get these people back in power by 2 p.m.? Scheduling coordinators, when we're doing planned work, we want to make sure that our customers know when they're going to be out of power. So, hey, listen, we're going to have this planned job, and it looks like these 8 customers are going to be out of power from 8 o'clock in the morning to 2 o'clock in the afternoon. How do we make sure that's well coordinated such that if something happens and it needs to be rescheduled, our customers can then be informed? As well as various distribution line technicians. We run a very smart grid here in California with a lot of investments being made on grid modernization that created a lot of computing power right at the edge of the grid. And we have to have specialized personnel who can make the necessary adjustments, install those smart devices, work with the operators to make sure that it's working correctly, because the operators use all of that information from our grid modernization plans on all of this technology that gets placed out into the field so that they can better operate the grid, that they have better visibility in what's happening on distributed energy resources, that they have a better visibility on what happens when things occur on the grid, like cars hitting poles and other type of things that may happen on the distribution grid, to better inform and restore power to everybody. And the thing about the control center operators, they actually don't see the color of the electron. They don't see a green electron, they don't see a red electron, they don't see a blue electron. They just see power's on or power's off. And how do we make sure that we as a grid operator can get as many people from the off period to the on period as fast as possible? We'll talk a little bit about how that works. So this gets to, what the heck does it even mean to operate the distribution grid? Utilities will talk about this all the time. We operate the grid, we operate the grid. 95% of the people may not even understand what that means to quote unquote operate the grid. And that could be a high percentage even within the utility itself, right? As we have a very diverse employee set, to understand what it means to quote unquote operate the grid can be a little bit, how would you say, difficult to kind of grasp. And so what we really want to demonstrate here with you today is, what is that? What does it mean to operate? I have the pleasure, because of being a distribution operator or running a distribution control center, to actually have in front of me the applications that we actually run on the control centers. This is PG&E's applications, not necessarily San Diego and Southern California. All of our applications look a little bit different since we all run different type of platforms. But I'm hoping that if you'll allow me to, I'm going to try to share what this system looks like. And then after we do this screen share, I think we can then turn it on to a time where we can ask questions about what we have, and then see if we can entertain some questions at that point. But before we do that, we're going to try to see if this works. And I apologize if it creates a little bit of a disruption, but I am going to pull this up. And Matt, can I confirm that you can see? All right, love the thumbs up. All right, welcome to the distribution management system. Now, this is PG&E service territory, and not only is this PG&E service territory, this is only about half of my PG&E service territory. Our system has so many line miles and is so complicated in terms of just the ability to operate. I can't actually put all my entire system on one screen. It takes that much effort. Now I'm sitting here at home with a VPN, so even my bandwidth is somewhat limited to what the control center operators have when they're directly plugged in. But as you can see, I am kind of demonstrating to you right here on the screen the distribution system of half of PG&E service territory. And you can see it is a spider web. Here's San Francisco. You can actually see the outline of San Francisco from the sheer circuitry that we have in the system, which is kind of cool to see. I'm sorry, I'm a little bit of a geek, I know. Now, as we kind of roll into this, you're going to see San Francisco, Oakland, you're going to see Napa Valley out here with the wine growers of Napa, and we can start to scroll into this a little bit more. Now, I can go ahead and turn on various maps. Oh, look, it's a map that actually shows the street view to be able to see how we go ahead and operate this via our neighborhoods. But there's actually one thing I do want to show you, which is some of the challenges that we have in a rapidly evolving climate. And that is high fire threat districts. What you're looking at is an overlay. And again, we do have circuits up here. We do have circuits over here. I can only show half of my service territory right now. But you can see this is the challenges of climate change. This is the high fire threat district map published by the Commission, where you can go ahead and see the red layers, which are the tier 3 high fire threat. The orange layers are the tier 2 high fire threat. And you look into areas where we operate, and you can see there is distribution circuits spiraling all into this area. And I don't remember it, and I remember a time where we didn't even have these type of high fire threat maps. And now with this type of intelligence and with this type of view, it is creating a different way of how we need to operate the grid. And I've been in the pleasure of being able to be also part of the microgrid related team that's also asking, how do we create microgrids in an area when it may not be safe to energize? Because of these complexities of this spider web of circuitry that moves into rapidly evolving climate here in California. Bark beetle devastations, followed by extreme drought, followed by extreme rain, followed by extreme heat. We've been seeing this for the past 5 to 10 years. That's creating a lot of challenges on how electricity can be safely delivered from that transmission bulk system down to our distribution customers to be able to create safe and reliable electricity for everybody. You're going to see all these different type of cool little colors. Each one of these is a different circuit. So think about your electric panel at home. You got the kitchen breaker, you got the dining room breaker, you got the living room breaker. If you go in here, I'm going to take a look at Silverado, for example. There is 1, 2, 3, 4 circuits coming out of that particular substation, each one with a different color. We talked a little bit about the radio network. Each one of these circuits is a different radio network. And as you can see and go back out here, it goes out from the substation here in Silverado and it branches out and it spirals out. And what this enables us to do is something happens on the blue circuit, it's not going to affect the purple circuit. If something happens on the green circuit, it's not going to affect the blue circuit. And similar to your house, if something happens, if a fault happens in your kitchen, it's not going to take out your entire home. The kitchen breaker will open, your kitchen will then be de-energized, and you're good to go. At least for your dining room and for your living room. And it's the same thing, if something happens in the bedroom, if some fault occurs in the bedroom breaker will open and you can still cook in your kitchen. It's a similar way here where if something happens on this circuit, the orange, the brown, the green, and the purple can remain energized. Now, it even gets even further where you see all these little flashing devices out here of different type of things that are on the system. And these are all particular devices that are actually installed on the feeders itself, on the circuits itself, on the overhead and the underground, that really allow us to say, even if this entire purple area, if something happens, maybe it only happens in a particular location on that. So think about like your kitchen again, I go back to this. Instead of breaking your entire kitchen and de-energizing your entire kitchen, if something were to happen, either we had to replace a plug or something short-circuited in your kitchen, I have the ability with these type of devices that says the entire purple doesn't get de-energized. Maybe only this section that goes from this little R thing right here to back over here will be de-energized if something were to happen, but the remaining portions of the purple will remain energized. So I think about this as your kitchen is, again, your stand mixer created a short circuit. I can still have my microwave. I can still have my refrigerator still working. And it really is that GFCI, plug that short circuited and really only allowed that plug to de-energize rather than opening up the breaker for my entire kitchen and then losing my entire kitchen itself. It's very similar on the distribution grid. We're going to talk a little bit about how we can reroute power in maybe a further area we can describe a little bit about here, and then we'll talk a little bit about the distributed energy resources impacts onto that. But I want us to all think about that kitchen example for an example. The interesting thing about the distribution system that's a little bit different than maybe your home wiring in your homes is I have the ability to take, for example, people who live on this circuit and are energized by these wires and move them to a different circuit. And you're going to see these little points where the colors change from brown to green in this instance. And we have these places where they may be different circuits. This might be the kitchen, this might be the dining room, but there are tie points between the two. And where this is very unsimilar to your house is that if I had a problem in my kitchen whereby this brown circuit was completely de-energized, I still need to use my stand mixer. My wife is a big baker. So, her ability to still use the stand mixer in case we lose the entire kitchen it would be pretty important. Now, in my household, I can actually technically move my stand mixer from the plug in the kitchen to the dining room. I live in Orinda. I can't just pick up my house and move it to Lafayette. That doesn't really work in today's world. However, we can take somebody, if this entire area is de-energized, with this brown circuit being de-energized, there might be opportunities for us to move this brown and move it onto the green. And what that means is, let's say I have the stand mixer plugged into my kitchen, but my kitchen breaker opens on the panel, and now my entire kitchen is de-energized. And since, in this current example, I can't move the stand mixer from the kitchen to the dining room plug, I can actually take that plug that stand mixer is currently plugged into, and I can reroute that over to the dining room. That's how the distribution system works if you think about it in your own home. Now, we might need to do some shenanigans on the distribution system, open up these switches, close some switches. I'm going to try not to bore you with that type of level of granularity. But what will end up happening is I might be able to take this section, open up this device, close this device, and now this portion that was brown turns green. And those customers are now being energized from this green if there's available capacity. And what that means is, let's say in your dining room, you have, a TV, you have, let's say a VCR, you got your Switch, Nintendo Switch, you got, some places even have within the dining room closet that has a washer and dryer. If I try to take the stand mixer and reroute power to the dining room, most of the times you'd be okay. But if it's a really tightly loaded dining room circuit, and I try to reroute power from that stand mixer over to the dining room, I might trip the dining room. There's not enough power within the dining room, not enough capability. It's already too heavily loaded. I've had this happen in my home all the time where I have too many things on in the kitchen, and now my kitchen breaker opens. When you're trying to run the microwave, you're trying to run the stand mixer, you're trying to run the rice cooker, and you're trying to run a pressure cooker all at the same time. Typically, sometimes, depending upon how your home is wired, that's can create problems, and now your breaker opens. So if your dining room is kind of like that, and you want to add the kitchen stand mixer in, and you don't know if you have enough availability in the dining room to be able to pick up that stand mixer, you might trip the entire dining room breaker. And now your kids are pissed off at you because you're trying to bake and they can't play their Nintendo Switch, and now you have a broken down household. Tantrums flying everywhere, right? So, that's where we have the similarities on the distribution grid, where our ability to understand what type of capacity we have available to pick up the stand mixer and put it onto the dining room is incredibly important. Because what we don't want to do is, if I'm picking up the dining room, if I'm picking up the stand mixer on the dining room, I don't want to de-energize everybody in the dining room. The TV gnome is not happy. The switch gnome is not happy. The washer and dryer gnome is not happy. We need to be able to make sure that we can do that. And that's kind of what we do on the distribution system as an operator, what our operators do. Now, it also takes a look for power quality. If I put the stand mixer into the dining room and the TV starts to flicker because there's just not enough power to be able to have that, or the voltage starts to do something funny and your kids are trying to play the Nintendo Switch while your television is flickering, that's probably not a good user experience for your kids trying to play the Nintendo Switch. The Switch is turning on and off and they're having all kinds of problems, and now they're yelling at mom for stop turning on the stand mixer because they can't play the Nintendo Switch. And so our operators do the same thing. They look at the power quality. If I move all of these customers onto a different circuit, will I introduce a power quality issue and now create flickering lights across all 4,000 customers? Now will rotating engines and industrial customers start to see dips in power quality such that now their engines are starting to really rev and start to burn out? These are things that our distribution operators are looking at, and they have to do things in a particular order. They can't just willy-nilly close a switch, open a switch, and hope everything works out. It takes an intense amount of studying, and it takes an intense amount of capability to be able to say, hey, can I do that safely? And can I do that with a high degree of confidence? And that interplay between our operators and engineers to be able to run a system of this nature is critical for us to be able to keep everybody in power, whether it's a DER developer who might be looking to export energy on this portion of the grid, whether it's a tribal community that's looking to operate a microgrid and still export its energy onto the grid. The major component that we need to make sure as we have these type of outage conditions, as we have this type of planned work on the system is, does everybody have access to the system? Can I get customers restored as fast as possible? And while I would love to be able to enable all these DERs to provide whatever they can, whenever they want, what I have to make sure is that everybody first has power. And we'll talk a little bit about what are some of the changing conditions that are going to be occurring on our distribution system as we move to a much more distributed grid in the future.
Thanks, Quinn. I think that's a good time for me to interject with a time check. We're a few minutes over schedule, and all this kitchen talk is getting me ready for a break. I wanted to suggest maybe we cover a couple of quick questions that have been posed in the Q&A, and then we'll take a break. The first question is, are behind the meter DERs visible on this platform? If not, how do you think about incorporating them?
That is a great question. Right now, I have what's considered a distribution management system. You'll hear some terminologies in the grid modernization framework of an advanced distribution management system. Right now, our tools do not have the capability to forecast DERs and what they're doing on the entire system. I might have visibility at the breaker level at a station. I might have visibility at these set points that you see with the R's where I can get some data coming in. But in terms of an individual DER, maybe at the end point, it has to be over a certain size. I believe it's 1 megawatt or above for me to be able to have information coming into my systems and say what they're doing at any given time. But typically we take a look at what's coming through, the information that's coming through these particular set points or back at the station, and that's what we have to use to operate. When we get to an advanced distribution management system that's a part of our grid modernization efforts, that's when we'll get much more intelligence coming in as long as it's being made available.
Thanks. And another question about what you can see. Do you have access to smart meter voltage reads when doing switching as you're describing?
That's a great question. The smart meter technology has definitely evolved. We don't have voltage for every single customer that exists at a 15-minute and 1-minute increment. If we had to all start back in smart meter way back when we first implemented that, I think that's something that we may have asked for. Being able to monitor the voltage fluctuations that were happening on the distribution grid at that level, would be huge. However, we do have the ability to get voltage information at certain meters across our entire service territory that enables us to monitor power quality and be able to identify partial voltage conditions that could help us identify where outages are. We also have a power quality team that can also then identify from smart meter historical data where we might need to target voltage related issues for normal day-to-day activities and put specific power quality meters at those particular areas where we're seeing some sort of issue happening on the smart meter voltage issue that we can then see if we can get more information through power quality meters to get a better understanding of voltage impacts on the system.
Great, thank you. And what about demand response in the context of a switching situation? Do you factor in the capability of demand response in a possible switching arrangement?
So I will say that I think that's going to be the future. The big thing about a distribution operator, though, is certainty. If I'm going to be using demand response for being able to move load from one place to another, what I need to know for absolute certainty that that load is going to disappear. And right now, our demand response programs and our DER programs may have some of that built in, but as a distribution operator, we need 100% certainty because what happens is if it doesn't work, if those individuals decide, yeah, that's great, I see a demand response signal, I'm going to ignore it, that creates problems for us because now I may have just overloaded something. I might have tied 4,000 customers to another 1,000, and now all 5,000 customers have problems. And that's where it gets back to, as a distribution operator, I need to have certainty because I'm putting customers' reliability at risk as I'm moving load to be able to take advantage of that restoration capability that we talked a little bit about of moving load around the system.
Great. Let's do one more question and then we'll take a break. What is a direct transfer trip? What do you use it for? How do you decide whether to install one? And if you're able to share, how much do they cost?
Oh, now we're getting into the details. We do have direct transfer trips on the system where, it's called different things. Direct transfer trips, in my terminology, if I understand where the question is coming from, is called FLISR, or the ability to take a system and do self-healing type of technologies. And what they're talking about here is that if something happens out there, power can be rerouted automatically without the operator even having to do anything because we have identified a set loading pattern and a set understanding of what can be transferred over where, that as soon as something happens, it can automatically do that. Now, I will say, if it's a high fire threat, some of that technology is going to be disabled, right? You don't want to do that if you're having to potentially test the system to see, did it work? Did it not work? Did it work? Did it not work? And sometimes the system does that. But during periods of non-higher fire threat areas, it does have that ability to automatically reroute power if there's the capability to do that. And we have, I don't know the exact number. I apologize. I don't have that off the top of my head, but a certain number of circuits that have that type of capability. And an ADMS system will actually be able to even enhance that even further.
All right, great. We're a few minutes past our schedule. So Rob, I'll defer to you on starting a break now. That's my suggestion.
Yeah, let's take a full 5-minute break. It's been great discussion, and then come back, like I said, 11:03.
Great. Thank you.
All right, we'll see everyone at 11:03. Take a break. Welcome back. I'll just note, we would like to still finish at roughly 11:40. That last discussion was excellent and really helpful to see the distribution management system. But we do want to make sure we try to finish on time or very close to it. And with that, I'll turn it back over to utilities and to Matthew.
Thank you. Appreciate that. And I think the follow-on conversations for the back half will actually go much faster. So I appreciate the urge. And so I did get, when somebody said about direct transfer trips, I completely got my skis crossed. We'll make sure that we answer that at the end of the meeting, which direct transfer trip is not Flizzr. And I apologize. My mind just kind of had a little bit of a brain blank on that. So I apologize. And we'll see if we can answer that at the end if we have time. So we wanted to now talk a little bit about, well, now what does this mean about having a high active DER penetration? And so I'm hoping that I can get this to work. So as we look at distributed energy resources and what that kind of coincides with operations, we're going to talk about four things: altered load profiles, abnormal configuration, mass load, and local circuit constraints versus system. And we'll try to go this in a fairly rapid pace. I'm going to show you two charts. You might have seen this in some of the grid modernization presentations, but this is kind of what we look at on DERs who like to participate on the market even before and after. This is actually a circuit, the SWIFT 21-0 something. I can't remember if it's a 2 or the 1. And what you're looking on the left is a very smooth load curve. You can see where the solar actually drops off, right about here, and a massive amount of load coming into the system. You can see just a nice predictable curve. This is what I see day in and day out, 24 hours, 365. This is super predictable. And what I use is I use this top portion here of available capacity to make decisions on how do I move load around? How much more customers can I place onto this circuit before we run into a thermal overload, which would be bad. If you take a look at what happens with a 4 megawatt battery associated with this particular circuit playing in the ISO market, you see this is what the battery does to this load. And you see just a jagged line is as it operates, in this case, in the ancillary services market, very much about a loss of this predictability that I have. This creates very limited capacity during the off hours. Now I have to pretend that everything is at peak. There are ways around this, right, to go from here to a much more predictable load shape, which will require participation and help from the DER community to be able to do that when I run a system that requires me at only certain times in the given year to require this type of predictability. But I did want to share with you, this is kind of some of the things that we look at in a higher DER world of what it's going to take for me to move load around between circuit to circuit when I have some sort of unplanned outage condition or a planned outage that I need to do work on and things to consider. We talked a little bit about abnormal circuit configuration where we're moving load around. I'm moving the stand mixer over to the dining room. But really where the challenges come into play is we have two energy storage devices here on station A. And typically you're fine. You have 14 megawatts of customers on there. You add in 2 megawatts of energy storage, and if it charges, gets you to about 16 megawatts. But if we're rated at 20, everything's fine. This is what we call the interconnection process. Hey, on a day-to-day condition, when you're on your normal configuration and everything was looking fine, a blue sky event, nothing's happening on the system, operate how you want, whenever you want, we're fine. And even in certain situations where we have problems on the system, a car hits the pole, and I want to pick up this portion of the Energize circuit and move it to this particular station. As we've talked about moving the stand mixer, right, over to the dining room. If we have the availability to be able to do so, you can see this station B looks like about 6 megawatts, 20 minus 14, 6 megawatts available. It can pick up 3 megawatts of customer load plus 2 megawatts of customer generation, still be underneath 20. If this is a pretty lightly loaded day, 14 megawatts worth of load on this particular station, yeah, sure, do whatever you want. I can pick up your ability to charge or discharge whenever you want. Operate as you see fit. But let's say we have a highly loaded day. And now I'm running 16 megawatts of load. Well, I have to pick up these 3 megawatts of customers plus 2 megawatts of energy storage, and now I'm at 21 megawatts if you do the math correctly. That's over the 20 megawatt rating of the particular station. That's going to create an overload. That's going to create problems for this entire system. And so these are just some of the things that we need to consider as we look to operate the system. Now, fortunately, you don't have cars hitting poles in the same exact location all the time. This happens relatively infrequently for our various customers throughout the entire period. However, it does happen. And so these are some, and we're talking about a very simplified 2 DERs, 2 storage devices, 1 megawatt apiece. You can just extrapolate the complications that could occur in the future as much more resources are now placed onto the system in much more locations and all doing things maybe slightly a bit differently on how we think about what we need to operate the system to make sure these 3 megawatts of customers, these customers may not have any type of DERs associated. They may be residentials, they may be a Walgreens, they may be a gas station. They just want power, right? Get me back in power. And we have to be able to make these type of restorations, which may cause us to take certain considerations like, hey, storage device out there, we might need you to not charge during this period of time because, hey, I can't take that additional load. So these are things that we're going to have to consider in the new world, and we're considering today. This is something as an interesting phenomenon that occurs in the system. And let's say every single one of your appliances had a solar panel associated to them. So your kitchen stand mixer, which uses a lot of electricity, has a solar panel during the day and actually doesn't pull very much from the plug. We don't have the ability to see that. In our systems, we just see what the energy is actually being pulled from the plug. What we don't see is how much energy is being offset from that solar panel that's attached to that stand mixer. Because that stand mixer is using the solar energy before it uses the actual grid. Now, this would be all fine and copacetic. You know, we're looking at the grid. We're like, oh yeah, this is fine. We're well below the capacity limit. Where this becomes a little bit of a problem is if I have an outage. And so when I have an outage that occurs on the system, what we know about DERs today is that solar doesn't come on right away as soon as I restore that circuit. It takes a little while for them to come back and generate electricity. It takes a while for energy storages to come back onto the system and discharge. What that means is when that stand mixer is running and the kitchen has an outage and I restore that kitchen, it's picking up that entire stand mixer. There's no solar offset. And that's where you get this masked load. And now this is picking up the entirety of everyone's load. And that could exceed the circuit capacity limit. We've had this happen where somebody will be like, hey, I'm only picking up this much load. Sure, close in, we'll restore these customers, and boom, it picks up all of this amount, and the circuit relays again, because it says I'm over capacity. And now I have to pick up the customers in smaller chunks so that we pick up a little bit, the solar comes down. Solar activates, brings down that load. We pick a little bit more, solar activates, comes back down. It just creates a little bit of a complication for us as it just takes a little bit longer to restore. And sometimes we're not exactly sure what happens. How did I pick up all this load I wasn't expecting because of this mass load phenomenon? And some of this will be definitely dealt with in more advanced distribution management systems that all of us have within our grid modernization plans. Lastly, I'll leave at this. This is my last slide, is about the issues between the system versus the local needs. And what we're really trying to outline here is for the most part of our service territory, for our most part of our circuits, the system and the distribution system looks very similar. You would expect that, right? At the system level is just an aggregation of everything that happens on the distribution side, and the customer load profiles, for the most part, look very similar to what our customer load profiles look like at the system. Where it creates complications is there's areas that do not. And if you think about like what happens in the month of March, we got a lot of agriculture pumps coming on that create this kind of dynamic where the load is much higher than what we expect. And so the California ISO on the system level may say, hey, listen, let's go ahead and get those batteries charged. We got cheap energy happening. Let's fire on all those energy storage assets. And over suddenly you have a condition on circuits that are really highly loaded because those ag pumps are running. And the correlation between the market prices and a local distribution load could be exactly the opposite. And so these are things that we need to create as we think about market structures for the future. What does the distribution look like? What does the system look like? And what happens if they don't correlate? What happens if those needs aren't the same? How do we think about marketplaces for that? As we try to create system level type of pricing signals, what does that look like? Do we want to have more distributed level pricing signals? Will that be interesting? What happens if I live on the Moraga 1103 and my neighbor lives on the Moraga 1104, but we have different type of constraints on our circuits? And now we have different pricing signals, even though we only live across the street from each other. Those are all things that we need to consider as we think about moving toward the future marketplaces and how the system is not entirely the aggregation of everything below it. And so that's all I have for my section. I can't remember if we were going to do a Q&A section from here. Matt, maybe you can remind me.
Yeah, Quentin, let's just cover one quick question and then we'll move to Mark to catch up on time. One question that's been posed here that I think fits is how will distribution system operators be positioned to manage the distribution system of large variable loads like DC fast chargers or large fleets?
Yeah, that's a great question. So I will say personally that, when the grid is operating in normal configuration, interconnection should make sure that everything is safe, reliable, voltage, hey, listen, when you're interconnecting to the grid, you're fine. When it comes to abnormal circuit where I'm got to figure out, can I move this load over? We are going to have the new tools in place with our ADMS systems to be able to really get to that more granular load forecast to say, here's what I'm picking up that's behind this particular wall. And it's, guess what? It's a huge DC fast charger. And if there are capabilities to say, hey, listen, I need us to curtail because I want to pick up these 2,000 customers and place them onto the circuit so I can get them back in power. And I need to curtail this circuit load for 4 hours. Can you guys help me out? That might be a new dynamic of what we're taking a look at when we're looking at these type of, various factors that happen on the distribution system and how do we interact with major load chains like DC fast chargers as we look to operate the system. I might have to tie multiple circuits together, multiple substations, move load all around. That could be possible in order to give everybody 100%, but that just puts a lot of people at risk that something could happen onto the system and creates a lot of work for the control centers to be able to enable that while they're dealing with other conditions that are happening on the grid. So those are just things that we need to consider as we look at the future of that.
Okay, great. And I'm going to raise one more question here and just ask you to perhaps address it through the remainder of the presentation or at the end of the presentation. I want to put it out as a seed here, but would determining community level needs improve load forecasting and therefore reduce the possibility of exceeding circuit capacity? Or I might paraphrase, as planners and operators, would knowing more about what the community is planning and expecting be useful inputs into your work? And again, I think it's a big and open question, perhaps not to address now, but to address through some of the subsequent slides and discussion.
That's
so
great.
For the sake of time, I'll let Mark keep going, and thank you all for the good questions that are coming in.
All right, thank you, Matt, and thank you, Quinn. So here we'll just go over here on what's going on the distribution grid in terms of external factors. And what we're showing you here is from a typical day in the life of distribution operations. There's many interactions that they have with several organizations internally within their own companies as well as externally. And other key items here that maybe to also cover is that they look at various time dimensions. I think the bread and butter operations is what we hear real time, where they're focused on what's happening now, what's happening in the next few hours. But also they get involved with the future grid, the future shaping of the grid, working with our asset management teams. They're providing their requirements on what they'd like to see included to help improve and help support their operations. And so I think But the picture of this slide here is really to show that there's many different groups that our operations teams are working on, and they're very difficult to spread apart to do it effectively. And it's really one integrated group looking across all these lines here. Next slide. So many folks were also kind of wondering, well, what's the difference between planning and operations, and what are their roles and their responsibilities, and how do they work together? Well, effectively, planning designs the grid. They come up with the plans and they identify kind of the necessary infrastructure, and operation operates it. The analogy, using analogies, as Quinn had mentioned, he was talking about the kitchen and the bedrooms, but I like to think of it as if you take the grid as a car. Planning and the asset management groups, we own that car. We identify kind of the necessary infrastructure upgrades to be able to operate, what's needed to operate that car to meet some of the future changes, the risks, the demands, whether it be wildfire, capacity needs, electrification, and really trying to factor in all the newest technologies and tools that are out there that we want to be able to leverage and utilize into the grid. So planning is looking at all those different dimensions, and operations, I view them as the driver of the car. So they're the folks that are operating that car, driving that car safely and reliable to ensure providing the service. And yet they also provide input back to planning to say, hey, when I'm operating this car, it'd be great if I had something like this. And so in a nutshell, really, that's kind of how we see the dichotomy and the push and pull between planning and operations. Planning does factor in put a future forecasted need from a demand and generation perspective. And as we've talked about, and we're going to talk about in other workshops, the need to get more granular to understand how the load profiles are going to be changing, and looking at multiple scenarios, because there may be different build outs here that may occur, and really identifying where the grid needs are going to be, and then working across various lines on, what are the best solutions? What are all the different alternatives that we should be considering? We have the GNA, the DIDF process that's out there, and more details will come about that in an upcoming meeting. And effectively, both groups coordinate well together. As I mentioned, the operators, the operations, they're the drivers of the car. They give feedback on what they'd like to see, how they'd like the car to operate based on some of the designs and kind of the future direction that we're looking at building out the car. Next slide. And so as external drivers are making change, a point to make here is that our operations, our distribution operations is evolving as well. It has been. So it's something that we're doing today as technology and some of these drivers are changing. Take example, wildfires, PSPS. Our operations group have stood up to the challenge and have continuously improved on how they manage those events, how they operate during those events, and factoring in the new technologies that are out there, the changes in policy, and the feedback that they're getting from planning on how we're adjusting the grid and factoring that into our grid operation. So they've already advanced in those areas today. And I know I speak for all IOUs that that's the case, but we know that our journey isn't done yet. We know that there's more that's going to be coming, more change, further evolution, and our operations group is definitely up for the challenge, and we're going to continue to involve with the rest of the stakeholders in California here. Next slide here. And so looking to the future here. So this is a nice little animation here. This is how our grid looks today. We have the larger conductors at the top of the chart here, closer to the substation with the squiggly line there representing where the demand is. And typically as the radial design is set up, that our conductors typically are sized smaller. We have from a demand perspective, and so the infrastructure there is sized appropriately. And then if you go one click into it, Quinn, then you start to see customer interconnections. Another click. With those interconnections, you start to see two-way power flow, power starting to flow back and forth. And then what we find out is our system now is under the process of being retrofit, redesigned to cover for those two-way flow. So it will come into conductor upgrades here. Next slide here. And then what you see here is voltage irregularities. And now we're leveraging smart inverters to be able to, handle some of those irregularities. Next slide. And then we may also have a peak load reduction request that's out there. And then the DERs are responding to those signals and being able to reduce demand in those areas. And so kind of the evolution of the grid, where it was from a one-way flow, and what you're seeing here is really a bi-directional flow with different devices responding to provide services to help the greater good of the grid. Next slide. So some of the capabilities that we're looking at here, and we've started to deploy some of these already, and we're continuing evolving it. We've talked a lot about the visibility aspect from DERs, looking at, understanding, trying to get situational awareness of, where different parts of our grid are at, the visibility of DERs and output. I think those are some things there that are looking into, as well as when you have that information, that helps improve the awareness to be able to, for DERs to be able to participate into necessary markets and others. So definitely a lot of activities there in the working groups that are ongoing, evolving what we're doing around smart inverters and the being able to communicate and respond, but also from an operational and planning dimension. I think what we're seeing in those aspects there is that we're getting more granular information to better improve our forecasting, and end result is that information is going to help improve the overall operation of the grid and help involve all customers. Advanced grid analytics. We're looking at this to come up with other different scenarios, identify issues before they actually occur, and through that there mitigate those issues, whether or not through a wires or a non-wire solution. And with that there, we're also looking at how can DERs be optimized to be able to help meet the needs of the grid. And as a result of that should reduce overall expenses on what we're spending on the grid and maximize opportunities for all customers for these services here. We've heard a little bit about this T&D interface. So there's additional coordination that we're going to continue to improve, evolve between the transmission and distribution systems, and that'll allow better awareness of what's going on in the distribution system to be able to participate in the different services on the transmission system and really avoid some of those operational conflicts that may occur. And then other things that we're looking at here, and I think there was some questions there about what's some of the infrastructure that would be needed. And really what we're looking at is more intelligent sensors, more automated devices, so that we can collect more situational awareness about what's going on in the grid there to be able to respond to emergencies, dispatches, other things of that nature there to provide a good customer experience for our customers. And the next slide here. So some key issues here to kind of walk away. Each of the utilities that you heard here, the distribution grids are pretty complex. I think if you go back to the original, that earlier slide between T&D, just the volume of devices, the length of miles, and something that we didn't get into is the number of interconnection points on distribution is far greater. And there's many different interactions with various entities to be able to safely and reliably operate the grid. And it's really important to mention that we're doing a lot of that today with all these evolutions, but we understand that more changes are coming and we're getting better prepared. Our operations group, they're integrated. It's going to be very, they're really intended to be integrated to operate seamlessly across all the different lines of organizations and all these different drivers that are out there. So it's critical that there's a strong coordination there. And then kind of the last point here, with all the different changes that are occurring, that have occurred over the last few years and are going to occur, we understand that it's evolving. So the challenges are out there, and we're projecting new challenges that are going to emerge. And so that's why there's really a big need to continue to find opportunities to maximize the ways to use distributed energy resources through grid modernization, things of that nature, so that we really are meeting these challenges, so that we're not pushed up against a crisis of having issues right in front of us. We're really positioning the grid, not only our planning, but our operations as well. I think that's kind of my last slide there, Quinn, and I'll hand it back to you, Matthew.
Great, thank you, Mark. Have some great questions collecting here in the Q&A. We have about 12 minutes to try to address some of those. So thank you for ending early and leaving time for that. Stepping back into some questions that were posed a little bit earlier, I wanted to ask, there was a question here for your example, Quinn, before the break on rerouting power to different circuits. Could you discuss what portions of that process an automated demand management system could automate? Is it
Certainly.
all of it, or is there still going to be manual interventions? And if there's going to be manual interventions, what do those look like within that context? I'm paraphrasing a little bit.
No, that's great. And I think an automated distribution management system does have advanced applications that enable it to recommend a particular pathway for energy routing. However, I will say that the ability to be able to reroute power in that way is not just a science, it's also a little bit of an art. And the operator will always be necessary to take a look at that. Is that the right order of ways to do that? Are there things that are happening on the grid that we're aware about, but the system may not, that could maybe make some differences? Also, we have a lot of things that are happening within the high fire threat areas that are creating new type of ways that we need to operate. You'll hear things like the enhanced power line safety shutoff protocols that we've had to place the system into have now almost 40% increased the number of switching steps that we need to take in order to move load around, as these types of settings, while they're very good at preventing wildfires by creating the necessary, protection on the system, also creates a lot of challenges for how we operate it. So I would always say that, the advanced distribution management system will definitely help us be more efficient, be able to figure out what's an initial recommendation on how we should do load switches, but the operator's eyes will always need to be there. The IBEW and the ESC engineers will always be required to take a close look at that. Is that the right way to go? Are there any type of misalignments? Is this the right order? Are there things that we're not thinking about in order to make sure that those switching orders are accurate for the safe, reliable system of everybody?
Quinn, I may add, I agree with everything you said there too. Is just with the consequences there of a misoperation or of actually having someone next to facilities where they can get physically hurt or worse. It's something there that I think we still have to take a closer look. I mean, we'd love to automate as much of the operations as possible, but when it gets down to it, there really has to be that comfortable and that certainty that as we perform this work, no one gets hurt.
Great, thank you. Another question here, coming back to one of the DER dynamics you pointed out before, Quinn, which is the correlation or sometimes lack thereof between feeder loads and wholesale prices, basically how the load is accruing at the distribution level relative to the wholesale bulk level. The question is, what's the upshot of the correlation between feeder load and wholesale price? Are the utilities suggesting any capabilities that might be possible when there's a correlation, or is that just something just something to consider point of view?
I would say that, the consideration here is that if it's highly correlated, then typically what you'd see is that the signals being sent over from the system to have DERs do something will benefit the distribution grid at the same time. Well, benefit may be the wrong word, but will not adversely impact the distribution system because they are going to be lowering load at the right time and injecting energy and raising load at the right time when they need to, for example, charge during low prices. Where the challenges become is where that's the opposite, and now the system is creating pricing signals for, let's say, a charge signal where our load is already really high on a particular distribution feeder. Or we have so much backfeed of solar, and now the system is saying, hey, discharge more energy into the system because prices are high, but now we have all this backfeed, and now we're putting even more generation onto the system. These are all just considerations that we need to figure out, and how do we kind of walk through what is capable for each location will be up to kind of our interconnection folks to really figure out and look at very closely to make sure that if there's an upgrade required, if there's constraints that we need to think about, that is being thought about at the onset of the interconnection process.
Yeah, and Quinn, I may also add, it's just it just really depends on the local areas. On like some areas may, and I think we all know this, that there's some areas that are more likely to adopt DERs because they're not as disadvantaged to do that, and some other areas not. And so it's not like a uniform spread of where distributed energy resources are going to be on the grid. And you know, we may have larger system-wide needs, and it may respond fine for that. But from a local level, there may be different needs at a local level, and so that's something that it just depends on, you know, really what the ratio of DER to load is in each of the local pockets.
All right, thank you. And here's another question that comes in medium speed right over the plate. Can you explain some of the ways that utilities see distributed energy resources and a two-way flow of energy benefiting the grid and the grid operator rather than creating challenges?
There could be situations where, let's say I'm performing switching and I have to do a complex load switch where I'm tying together two stations across multiple feeders and having to do a lot of complex related activity, that we could potentially simplify the number of steps that we need to do those load transfers by dispatching distributed energy resources at the right time. As long as we have certainty. We know that those resources are there. We know those resources respond to the amount that we need them over the period of time that need is there. You know, we also have certain situations where, like, our crew, we tell our crews, you gotta switch between the hours. You gotta do your work between the hours of 2 o'clock in the morning and 3 o'clock in the afternoon, and you gotta get off that circuit before 3 p.m. Otherwise, we'll face overloads. Well, you know, there could be aspects where if we had distributed energy resources in the right locations with that type of certainty to be able to lower the load at the right times, that we might have to have a crew come out at 2 o'clock in the morning. They may be able to start at 7 in the morning and end at 4 p.m. And kind of help better manage the workforce that way. So I think that there are opportunities on the distribution side, and our DIF process does identify locations where DERs can, mitigate or defer or even eliminate distribution asset needs, as long as it's cost effective for our customers. And so, yeah, I believe that there's a lot of opportunity there where it's not just a challenge, but actually a benefit to the distribution grid. It's about need, reliability. Can it really meet it? Because if it's half baked, you'll still overload the circuit. I can't have half of the need actually being reduced, because I need all of that need over that right period of time to actually show up for me to be able to say, yes, I can make this move.
I think we'll be working with that question for months to come. Thank you for getting us started. Let me wrap up this session by coming back to the question I seeded a bit earlier, which is a little bit outside the four corners of your presentation, but I know that will be familiar to all of you. Is you ultimately are serving customers and communities. How do you get information about what those customers and communities want or are planning in terms of their own distributed energy resources? And how does that information flow into your preparation of the grid and then operation of the grid to maximize the well-being of the grid and reduce costs and serve customers and achieve the sort of things we're trying to achieve here?
So maybe I'll start. I will tell you that I'm not a planner, so I'm going to leave it back to Marcus Guerra, who might be a little bit more attuned to this and to help with this. Here's what I would say is that, first off, with every single interconnection request, we get an ability to see what type of new loads are going to be coming into the system. The challenge is really around, like, planning, for example, city planning. And if a city or a county is going to be planning for additional load, it's about the certainty of whether that load will really appear, because what ends up happening is the entire ratepayers across the entire system pay for those upgrades to a certain extent, to most of the extent. And so how do we gain assurances on our side that that load will really be there at the right timing that they're forecasting so that we can make the appropriate upgrades at the right times that are going to be paid for all ratepayers across the entire service territory. If a Bakersfield growth project is going to be paid by all ratepayers, whether you're in San Francisco, whether you're in Santa Barbara, Santa Cruz, right? How do we have that type of assurances to know that that load will be there, such that we don't have stranded assets? The folks in North Valley aren't paying for stranded capacity investments where the load didn't show up as was projected. And now we have a massive $30 million investment that we made on the system for the load that never really appeared. Is a question that we have about how do we interact with our cities and communities with that type of planning, and at the same time be able to make sure that we're protecting all ratepayers from stranded asset investment is a question. I would say also we're partnering very closely with high-speed chargers out there to be able to ensure that we understand where they're going to be, when do they think they're going to be, so that we can get really ahead of that. As we think about the 5 corridor that runs up and down Northern and Southern California, that's going to be extremely important to make sure that we're building in the right places at the right times to meet this new EV load that's coming into our system.
Yeah, and I'll just add, I think Quinn did a good job of answering that there. And having worked at PG&E and now at Southern California Edison, definitely a lot of similarities there. And I think the same would probably hold true for San Diego, that there's a lot of work, a lot of communication that's done at a local level. So I know we have our customer teams that meet pretty regularly with our city and counties to understand what their plans are. And really understand, sometimes we get requests on really what's the load serving capability, the reliability capability area, and what are our plans. And really, I think those are the times that I think it would be good to share information. I think the challenge, as Quinn pointed out, is really the level of certainty about when is that demand really going to get there. So I think once we can get better certainty on that, that helps each IOUs with their planning and development on how they want to move forward. Now, one thing that I can speak to for at Edison, what we're doing is we're studying a few more scenarios in our planning process, really looking at different projections of growth of transportation, electrification, distributed energy resources, you name it, really trying to understand that spectrum of where the growth is going to materialize and the impacts on the grid, and really try to understand how this fits in there and really get ahead of the curve, because really it's all about early planning for us. So anyway, that's my add on to it.
Great. But thank you both for those responses. And I'm sure there's a lot more to follow on that subject as well. There's many questions that we didn't get to in the Q&A bar. I invite utility folks to weigh in on those questions if you get a chance through the remainder of the day. Questions that we can't get to here, we will take with us as items on our to-do list to follow up on for future educational opportunities. And with that, I'll wrap up this session and hand it back to you, Rob.
Wow, great job on timing, everyone. We're right on schedule. And that was an excellent presentation. I think you broke down very technical matters into the kitchen based on a card, and you tried very hard to take, I think, technical content and make it accessible. So thank you for that. I'm very glad it's also recorded, and so folks can go back to this in the future. With that, let's take a little break. Full 5 minutes, so 11:46 is what I'm seeing. So 11:46, we'll see you back here, and we'll be welcoming Dr. Lorenzo.
Thank you.
Right. Welcome back. And Lorenzo, I've elevated you to the presenter, so you should be able to share your slides and also maybe do a sound check here.
All right, shall I go ahead and do that? How's the sound?
You sound great.
Okay, thanks. Okay, I'll share the screen now and let's see how it works.
But it has been a little slow for me to show. There's that, I'm sure you see it, that share button at the bottom, and you select either a screen or you can select a window. That's how WebEx usually works. A window would be like a PDF document, for example.
So, sharing. I'm running into a little challenge here with my settings that apparently doesn't want to allow me to share.
Okay. Well, I've got the slides. Ones you
Let me,
just would you like me to go ahead and share?
Let me try one thing here and see if it works.
Sure.
Teams, go WebEx meetings. Okay, it's gonna require me to leave the event and log back in. Sorry for the delay, but it should happen quickly.
Hopefully that works. Oh, Lorenzo has left the meeting and he'll be back shortly.
So this is where we fill in with jokes.
Yeah, yeah. How about, can anyone guess what's in my background? It's
I won't, because I probably already know, but I won't cheat.
I can't
Maybe
choose either.
while we're waiting for Lorenzo, I wanted to invite folks to think about terminology that came up during that first presentation or that may come up in this later presentation, which maybe flows easily from the presenters, but lands less easily for our audience. And invite you to share with us terms that just aren't making any sense or just seem to mean things to the presenter but don't mean anything to you. And don't be shy about recognizing that possibility because there are many opportunities for it here. And as we move forward and have a conversation with one another about how these things work and how they may work in the future, it's critical that we are using terms in a way that works for everyone and that is engaging. So please feel free to let us know if you're hearing basic terminology that you feel needs to be explained or introduced further.
Yeah, that's a great suggestion. Also, I just want to toot everyone's horn a little bit for the large participation today. I think we peaked out around 215 and we've only gone down about 10% from there. So great for everyone sticking around, and hopefully this is helpful material, and we have a lot more great material coming up as soon as we have Lorenzo back on. Maybe as a backup, if he does have trouble, we can do his slides for him.
We can try.
Yeah, which is very hard.
Not easy to do. Yeah. Well, why don't let me looking at his slides here. Well, let's give him a few minutes, but I could share them and we could take a few things and he could start off, for example, on slide 5. But let's give him a few minutes.
Just a suggestion for consideration. Maybe we can take a couple more questions from the Q&A while we wait.
Yeah, that's a good idea. Those would be directed at the utilities. And so Quinn, I hope you're still with us. Let's see, Quinn and others from the utilities. I think they are.
We had one question from Brad Hebner, who asked of the utilities, is it possible to group circuits into categories? Those that have profiles that are closely aligned with the system profile, and those that differ in one way or another. And related to that, another participant asked, IOU TOU rates for loads tend to be high for 4 to 9 p.m. This price signal is optimal from a bulk perspective. Is it optimal from a distribution operations perspective? So there's a lot of interest here in that relationship between loading on the wholesale bulk side and the distribution side.
Hey, Matthew, I could take the second one. That's the one I remember most recently. So it would largely depend. Like, so 4 to 9 is typically probably going to be more symptomatic of heavy residential loads. People have come home and are turning on their lights or running their ACs or cooking and spending time there. So I'd say, 4 to 9, like, if you have those distribution circuits that are more residential versus those that are going to be, let's say, more industrial or more commercial, where they're probably more kind of like normal business hours type of operation. And then other variations that could happen in there, obviously seasonality, the type of season that you're in. Obviously, during like the burr months where lighting probably comes on a little earlier, and they have things like Christmas lights and others and things of that nature, that can change as well. And it'll also depend on where you are in the service territory. Is it typically a summer peaking area? Some areas are more winter peaking, so it can vary and depend on that question.
Yeah, and I would say for the most cases, TOU rates meet a distribution in terms of lowering load during the right periods of time. Again, the 4 to 9, from a solar dropping off period tends to be very also beneficial for a lot of the areas where there's a lot of solar on the grid, right? And being able to kind of manage the loads that we're seeing on the increase in spike of loads that occur during that period of time when the solar starts to drop off. Again, it's not all the same across the entire service territory, but my graph did depict that it's on the vast majority of the time, it's well correlated. But sometimes it's not.
You might be on mute there, Matthew.
Sorry about that. Another question, how long can a circuit be overloaded safely? When you talk about solar and storage taking a while to come on, how long are we talking about? Are we talking about minutes, seconds, sub-seconds? What sort of timeframes are you dealing with here at circuit loading and responding to those over or underloading conditions?
I'm going to defer to Mark maybe a little bit about, how long can something be safely overloaded. I will say, though, from our perspective, we have protected devices that look for a specific load limit. If it sees that load limit being exceeded, it will open and de-energize. And that's really to protect the system, and it's also to protect the equipment, to make sure that we don't have any type of thermal overloads that could create damage to our equipment, which is very expensive to replace. So, in terms of how long something can be overloaded, I'd probably need to defer back over to Marcus Scara, but the protected devices are there to prevent that from happening.
Yeah, I would just kind of second that there. Like, we typically design our system so if we do have overcurrent and instantaneous current, if it gets above certain levels, we trip it based off of kind of the dimensions of time there. So once it signals that we're approaching, it'll trip off there. But as far as like when does the equipment go into a failure, from being overloaded, I guess that gets into the actual integrity of the equipment, the age, the condition, the history that it's been. It's something that typically utilities are working to be more data driven, to try to target the replacement before the failures that have occurred. So it would, if you're looking at kind of the physical integrity, would depend on a lot of different factors.
Yeah, I agree with both Quinn and Mark on this one. In operations, we do have limits. We can go above it, emergency ratings, but there are protected devices like Quinn alluded to. Also, what Mark alluded to is there could be craftsmanship issues that could have been installed in the 1930s, and we don't want to push the thermal limits to those conductors and those connections. So once the operator sees the condition and sees it going over the limit or the amperage of that equipment, they're going to take corrective actions. That might be offloading a portion of the circuit up to de-energizing for safety and going out there, and hopefully we can reconductor that area.
I will say
Thank you, Dan. I just want to stop there. Matthew, we do have Lorenzo back.
I'm back. Sorry very much for that glitch. It just shows the importance of testing things before you actually run them in real time. But it sounds like you filled the time with some good responses to questions. So, okay, we should be ready now to share screen. So hopefully this works.
And if not, don't leave, Lorenzo. I'll share for you, but give it a go.
Okay.
The issue might be that I elevated you to presenter and you came in as an attendee. That's all I can think of. But just give me the thumbs up to share if you'd like.
I'm close.
Okay.
Here we go. Okay. Do you see a little thing that says it's loading?
Negative. All we see is your black screen, Lorenzo.
It's telling me it's loading my file.
We see the screen now. We see your slides.
Oh, you do? Okay, you're seeing them before I do.
I don't. Does everybody see the slides besides me?
No.
No.
Now
There
we
it
do.
is.
Or now.
There it is.
Okay.
Success. I'll turn it over to you there. We're just about 10 minutes late, but we could go a little long if you'd like into lunch. Up to you.
Okay, thanks. Although I don't want people to starve, so I will do my best to move through this quickly. So we're going to shift gears. It's my utility colleagues have really done a great job of setting a high bar here. So we are going to shift from the more technical operational kinds of details into the questions that are really at the center of this track 2, which is how do we compare different DSO models? And what I want to do here is establish some concepts and some vocabulary for how to go about doing that. Now, I have to say at the outset that I am not representing anyone here but myself. I've been talking and writing about DSO issues since 2013. In fact, it was 9 years ago this month that I first raised the idea of DSO at a CEC IPER workshop, August 2013. So I've really been working on these ideas for a long time, and I'm really expressing what I have to share and offer in this context, but not representing anybody else. So I want to start with takeaways because these are things that I'll come back to at the end that I'll explain more fully as we go along, but I think it's good to keep in mind where we're going. So first of all, DSO is not a well-defined thing. And that's for our context. DSO is a placeholder for some future distribution provider that we're going to be designing in track 2 of this proceeding. Now, step outside of our current context, and the DSO is used differently. In Europe, the distribution utilities are called DSOs. In England, DSO is more a destination of the future of where it's going. So what we're doing here is recognizing that people are using the word in a lot of different ways, but our mission is to think about alternative ways to design it and at some point get to a future design. Second, DSO is not optional, and I think that should be obvious from the conversations that the utility folks presented this morning. DER growth is happening, and a high DER grid simply requires certain distribution system functional capabilities that will need to be upgraded because it was not designed for a world where we have devices of different types and different behaviors on the grid and so on. So we're going towards some future yet to be figured out, but we're working on it in this track. The third point, roles and functions are building blocks of the system. And that will be an important emphasis here, that we need to think about roles and functions independently of the actors who perform them. And I'll explain that a little bit more shortly. But the main point is that things that we've been talking about this morning, a lot of the technical capabilities and those sorts of things, when we get to comparing different DSO models, what makes them different is what are their functional responsibilities? Who does what in this high DER future system? And we'll see that there are significant choices to be made as to what the DSO does, as to what other actors might do. And it's those different ways of making those choices that give rise to different DSO models. So I will emphasize this distinction of roles and functions. And then bullet 4, a DSO model is an assignment of roles and functions to the DSO and then specifying how the DSO is supposed to interact with the other actors in a system. So we will see some examples of alternative DSO models, and in fact, the GridWorks white paper provided some examples of different DSO models, and how they differ will be in what are they responsible for, how do they interact with the other parties. And then finally, alternative DSO models should be evaluated against specific goals, performance requirements, and guiding principles that we agree upon up front. And this, I believe, is a topic of the next workshop in this series. So what is a DSO and why think about it? Now I'm going to retrace our steps a little bit to build the case for those takeaways. The context that we're in, and this really describes to a large extent why DERs are growing. That as we look to the rest of this decade and beyond, we have three major goals facing society regarding energy and electricity specifically that weren't really big issues in the 20th century. Sustainability is one, and with energy that translates into transitioning away from damaging energy systems, ones that damage the environment, damage ecosystems, disrupt climate cycles, and so on. And that generally translates into decarbonizing, which, as we will see, gets expressed in terms of electrifying uses of fossil fuels. That really was not an issue in the 20th century, and as a result, the system that was created needs some tweaking in order to move to this goal. A next goal is resilience. Reliability has always been a goal, but resilience as we think of it today is when there are major disruptions that happen to the system, most of them climate relating, as we're seeing related to drought, wildfires, hurricanes in other parts of the country, and the frequency and severity of these events is increasing. How do we make sure that that we minimize the adverse impacts on people and communities by finding ways to maintain electricity service or quickly recover when there's a major disruption? And then the third big one, energy justice, equitable distribution of benefits and burdens, mitigating past inequities, and to pick up on something that Vice Chair Gunda mentioned this morning, that it goes beyond really remediating past inequities, but also thinking about going forward into the future. How do all communities play a role in this future that we're moving into? And a lot of that will feature distributed resources. And we do these things, these three new goals, really without compromising the traditional ones. Reliability, affordability, safety, these are still important. They just need to be addressed alongside these other ones. But as a result, and with the arrival of very powerful new types of DER technologies, we see that customers and local governments are adopting are adopting climate goals, electrification goals, things that are related to the quality of life of the people in their jurisdictions, things related to transportation, housing, land use, and so on, where doing things at a local level may have DER-based approaches that help them solve the problems they're trying to solve. So we see as a result, this is all driving adoption of DERs. So just a few quotes, and this really just reiterates what you heard this morning from Gabe in going through some of these bullets about this OIR. It's really not to set policy on numbers, but it really is trying to, and I'll go right to the bottom here, capture as much value as possible from DERs and mitigate any unintended negative impacts. Those are really the crucial things we're trying to do here. But this page is just quotes taken right out of the OIR. So why talk about a DSO? Well, there are two really major implications for the electricity system when we think about growth of DER. The first one you heard in great detail this morning, that is the traditional function of electric distribution is not adequate for the future. That traditional function, and this comes out of the NERC technical model, one-way delivery of kilowatts. You can read the description of distribution service. It says deliver energy or power one way from the bulk system to customers. Well, that worked for quite a long time, but in this future we're moving into, it's not adequate. So addressing that basic inadequacy through functional enhancements and some regulatory provisions that accompany those is really necessary and not something that we can avoid. The second one goes to the adoption that customers are exhibiting for DERs. If we just look at adoption for the private benefits and we just let customers do what they want and then view passively how do we deal with their impact, well, that's going to leave benefits on the table, specifically grid benefits and societal benefits. Grid benefits, reduced infrastructure potentially, flattening peak demands, managing loading on circuits and so on, as well as societal benefits towards decarbonization, resilience, and energy justice. Private adoption by individual customers may meet their needs, but to go back to the Commission's statement in the OIR, how do we maximize the benefits? And so it needs to find ways that besides the private benefits that may drive adoption and even operation of customer-side DERs, we need to think about how to utilize them for these larger benefits. And that comes down to performance upgrades and new regulatory provisions that are going to aim towards realizing those benefits. What does the future look like? I throw this out as just kind of a general sketch. There's really not enough concreteness here to say that I'm advocating a particular thing. It's really just to say that the left-hand side of this, the distribution side, is going to be pretty much an equal partner to the bulk power system in terms of the future that we're moving into. The right-hand side, the Western interconnection where we live, individual balancing authorities, sometimes called a transmission system operator. In our case, it's the California ISO, which is the balancing authority. That regional system still does very much what it's always done, which is moving bulk power around over long distances throughout the Western region. And that's changing, of course. There are new things happening there. But in terms of what its primary function is, it continues as it's been, with the new mission of renewable energy and so on. But on the left, that's where really all the growth and action is happening that we're talking about. I use the term local distribution area, and that came up in a couple of questions in the chat today, an LDA, and that's just a shorthand to say that each of these areas, this blue circle, is connected by a single transmission distribution interface, that's the substation that was mentioned this morning, to a balancing authority area. So that's where the investor-owned utility systems connected these substations to the CAISO system and that boundary between transmission and distribution. Within that local system, which will be the unit of analysis here, there are all sorts of new types of devices, individual customers that may have behind the meter DERs, whether they're residential or commercial, industrial, ag, etc. Smart buildings are new things that are growing, the idea of multi-customer microgrids, and also front of meter DERs, the idea of standalone solar or solar plus storage systems that are coming online, or just battery storage systems that are coming online connected at distribution level. They're all part of this ecosystem in the distribution, local distribution area. So the idea of this picture really is to just sort of think of this bimodal system where the two parts are more like equal partners, in contrast to the 20th century view where the left-hand side was just a one-way transport service. So the question then becomes, what kind of DSO is best for California? If it's not a uniquely defined thing, it's a placeholder for this future evolution, then the question is not, do we want a DSO or not? If we really are moving into high DER, then the traditional distribution utility has to be upgraded with new functional capabilities. So the question then is, well, what kind of DSO is best? And there, I don't want to start from an absolute blank slate or zero. There are two primary core functions, which I think ought to be pretty obvious at this point, and they were topics of conversation this morning in the presentations. Two primary core functions: provide a reliable, cost-effective distribution network for basically everyone who's interconnected to that system. Providing that reliable service is essential core function. Second, coordinating with the bulk transmission operator, the balancing authority in general, but in our situation, the CAISO at the TD interfaces. Those are the primary core functions. But even saying that, there's a lot of detail to be spelled out in exactly how does it perform those functions. So a little bit of the logical thinking of how we get from societal goals to a preferred model. I've got this four-step building block which comes out of work that I've done in grid architecture that just says, well, you really want to start with what are the goals that we're trying to accomplish? What are the societal goals the electricity system must support? I listed three at the beginning: sustainability, resilience, and energy justice or equity, but this will be a topic of conversation in an upcoming workshop, and we'll all participate in that conversation. Once you have the large societal goals, then step two says, well, what does the electricity system need to do? How must it perform in order to support those goals? And there you'll get to things like integrating larger quantities of renewable generation, enabling customers to have choice over how they meet their local needs through on-site equipment, various aspects of performance that become important. So as we move into the upcoming workshop, and I think I read in the notice for today's that a future workshop, probably the next one in the series, the title of it was Vision and Objectives for a Future Grid. So we will be discussing these steps 1 and 2 in the future. And one thing to keep in mind is that it's really these steps that start to provide criteria for evaluating DSO models. In other words, we'll want to ask, how well do these alternative models meet the societal goals that we're trying to accomplish? How well do they meet the performance requirements that we want on the power system? Step 3 then, once we get into how we want the system to perform, then we start identifying specific roles and functions. And I'll say a little bit more about what that means, that comprise the operation of the system. Roles are a very high-level functional specification of different roles really that actors play in the system, and I'll come back to that in a moment. And then step 4, let's start to construct DSO models based on those roles and then compare them based on the criteria. So today's DSO 101 is just introductory material for steps 3 and 4. We will, in future workshops, getting into those in a lot of detail. But for today, some concepts, some terminology, strategies, and tools tools for designing the models, and then we'll end up with a taxonomy of different DSO models linked back to what you saw in the GridWorks paper a couple of months ago. The end of all of this comes out with selecting a preferred DSO model or models, and I put the S in parentheses, but my understanding of this track of the OIR is that it may well end up with more than one DSO model and feed into a future proceeding that will compare those alternatives in more detail. So we may just end up with specifying 2 or 3 that we say, gee, these look the most promising, let's compare them in more depth. But in any event, it's this 4-step process that gets us there. So from there, we can go into key terms and concepts. Matthew, let me just check with you. When did you want to take a Q&A break?
Now, let me let you take a breath. We got a couple of questions in here, and there's some good ones to help us get oriented. So we have a question. Terminology can indeed be challenging here. Based on Lorenzo's slide 3, the status quo is a form of DSO model, right? And therefore, we could also say that adjustments to the status quo may be a DSO model under this definition. Want to give you a chance to respond to that.
Well, I think that makes perfect sense. It could be, I mean, that's sort of the implementation step. We can define what the DSO models are in terms of functional roles and responsibilities. And then the question is, how do we implement it? And it could be that one path for implementation could be to make some adjustments to the existing distribution utility, and that gets us there. So that certainly is a plausible possibility.
Great. And this is going to come up a little bit later, but we have a question introducing the term distribution market operator. Could you explain what that is and where it fits relative to distribution system operator?
Sure. So good question. And when I think about the distribution system operator, well, I start with the operator of the network, the first core function that I said. It has these 2 core functions. A would be just providing an effective distribution network. Now, if we think about markets on distribution side, and I'm using markets in a very broad term, wherever there may be, say, competitive opportunities for alternative parties to offer services and procure services. So if we think about, say, for example, through distribution planning, the utilities identify some specific areas where DER solutions could substitute for an infrastructure upgrade. They might conduct a market process in the form of, say, a competitive RFP to allow different entities to offer solutions to meet that distribution upgrade need. We could have markets in which, going further, customers that have excess energy that they're producing on site have an ability to sell those into a local market or to trade those in some ways. This has been a topic of conversation in many areas, the idea of peer-to-peer trading, whether that's possible or not. But so there are a lot of different ways we can configure markets. We can think about FERC Order 2222, which says that distributed resources and aggregations should be able to participate in the ISO wholesale market. Well, that's a form of moving the wholesale market down to distribution level to expand participation. So at this point, and for today, I'm not going to get into specifics of different kinds of markets, but just to put out the idea that an entity who's operating a market on distribution might be a different entity from who's responsible for the functioning of the system in real time. And indeed, in Australia, we heard from Mark Patterson back in May that they're looking at a model there where there's a market operator that's separate from the network operator, and they have 2 different entities operating those. So we'll just give a little bit of attention to markets today, but that'll mainly be a topic for later.
Great. And there was more interest in the Q&A about international or outside of California examples of where DSOs are operational. It may be premature to dive into that at the moment, but given the focus of your your slides so far is really about why we need to talk about a DSO. Is there anything that you would pull from other examples outside of California that have prompted DSO conversations that we should reflect on?
Well, I think the places where I've been seeing the most interesting conversations on DSOs have been Australia, United Kingdom, and Ontario, Canada. And in Ontario, the IESO Independent System Operator, they run the power grid for the province. And then there are some 50-something distribution utilities that are thinking about, in the past, their role was very limited, which was very much like this one-way delivery of kilowatt hours. But they're thinking about how do they evolve those into a high DER future. So they're asking in some of the activities in Ontario some of the same questions. The UK started earlier on this. They started in 2017 to look at DSO models and how does the distribution utility evolve into the future. And there are some good papers by two of their distribution companies. One of them is UK Power Networks, which serves London and the southeast part of the country, and another one, Western Power Distribution, which serves the western part of the country. These are the two biggest, and they've both done strategic planning type papers about how they might evolve into future DSOs. So I think those are worth looking at for some examples. And there's grid architecture work that's been done. AMO just came out with a future grid study for Australia. That's the Australia Electricity Market Operator. So those are the three that I'm most familiar with, and I think it's good to take a look at what they're doing.
Great. Why don't we forge ahead and dive into key terms and concepts?
Okay. So what is a DSO model? I mentioned this in our upfront takeaways, but basically a model is a specific way of assigning functional roles and responsibilities to an entity that we'll call the DSO. And that is laying out first at a high level, like network operator, market operator, and some of those things, but then at a more detailed level, what is it supposed to do? And not only what is it supposed to do, but that affects what other actors as part of this ecosystem are all responsible to do. So we recognize that it's some functional enhancement of the traditional electric distribution utility, but it will have a bundle of functional roles and responsibilities, as well as the second item, second bullet, specifying what kinds of interactions it has with other actors. And many of those are obvious. For example, the interconnection process. How does it bring new systems and interact with customers who want to be network users? How does it interact with the ISO? How does it interact with communities? How does it interact with third-party DER providers? So those basic elements then comprise a DSO model. And when we look at them and compare them, how they'll differ is in questions of who's responsible for what. Now, noting though that DSO is part of a large complex system, which is the whole power system that has to function as a coherent whole, any DSO model we choose will have implications for what the other actors are responsible for doing. So, simple example, the more the DSO takes responsibility for coordinating the activities of DERs, the less DER coordination the ISO has to do. We'll see some examples to say how we could define a DSO that takes on a whole lot of responsibility and the ISO doesn't need to do a whole lot because the DSO is doing it. Similarly, talking about DER coordination in a way that smooths net load profiles, it's possible, say, to incorporate in a functional role of the DSO to say, we want to create as flat as possible a net load profile at the TD interface and to manage all of the short-term volatility. Well, if the DSO takes on that responsibility, that's going to reduce operational impacts on the ISO. That's going to reduce the severity of the duck curve, for example. So what the DSO does and how we think about which functional roles are desirable really has to also consider how that impacts other parties, other actors as part of the system. The basic concept of functional roles and actors, I like Quinn's use of the household today, so it gives me an opportunity to build on it. We can think of functional roles in a household. What do you have to do to maintain a household, a family? Pay the bills, earn money, buy food, maintain vehicles, do laundry, prepare meals. There's all these things on the left, and they're just functional roles. They're defined, and you can define them into some granular detail as to what's entailed with fulfilling that role. But they're not defined in terms of who does it. So then on the right, you have the actors in the household. In this household, we happen to have grandma, mom and dad, brother and sister, and Sparky the dog. And they each have some responsibilities related to those functional roles. In some case, a single actor may entirely take on a functional role. So we see that dad is the only one with number one. Dad he's the accountant. He's paying all the bills. But when it comes to earning money, number two, mom and brother are both playing part of that role. They're both contributing earnings to the household, and so on. Sparky the dog, her only job is with regard to feeding and walking. But you get the idea that you can assign roles to actors in different ways that can make sense. So going on that then, here are some of the main functional roles to think about in the electricity system. Now, this is not everything, but it's a sample of roles that we will be talking about. I talked about the DNO, distribution network operator, as distinct from distribution market operator, as they're talking about in the Australia model. The network operator is just making sure that the network services the physical operation of the system for the customers, and the interconnected DER reliably operates in real time. That can also include stuff like interconnection and planning so that the system is adequate to operate appropriately in real time. But if there are markets on distribution side, it could be a different functional role to operate those markets. And I'm using DMO for that. Now, I also want to distinguish DO, which is the traditional distribution owner, and that is the entity who owns, maintains, and operates the network assets, which could be a distinct functional role from the other two. And you'll recall from the examples discussed in the GridWorks white paper, they raised as a prominent design question, do we want to separate the DSO from the ownership of the network assets? That's a design question. So I'm singling it out as a distinct functional role. LSE, load serving entity. In other places, that's called the retailer. Australia, UK, they call them retailers. They aggregate end-use customers for procuring energy from the grid and supplying it to the customers. Meter data management authority. I separate that out because we kind of tend to overlook it in our modern conversations, but going back to the 1990s, I was involved in the retail side restructuring right after the legislation came out to create the ISO and the power exchange and wholesale markets. And there was a retail side counterpart about direct access. I was working for the Energy Commission then, and I participated in these working groups some run by the PUC, run by the utilities, where we talked about how do we structure activities on the retail side to enable retail competition. And one thing that was an outcome of that was the creation of a role that they called Meter Data Management Authority, which is the entity to collect and validate and maintain revenue metering. You could also include telemetry data in there, and then providing that meter out to eligible parties. It became important then because of the recognition that once you move into a retail direct access realm, multiple parties need access to the same data. Their financial transactions require access to that meter data, whereas in the prior bundled utility world, it was really just internal to the utility that it was needed. The question came up was, well, could a third party play that role? So I just identify it as a function here, something to consider. Now, the bottom three, the next three are all about the bulk system, transmission system operator or balancing authority, and then the energy market operator. Similarly, as I said, for distribution, where the network operator and market operator could be separate entities. Similarly, transmission system operator and energy market operator could be separate entities. And indeed, this is the system that we see in Europe and in the UK, where the transmission system operators really are balancing authorities, but there are energy markets, day ahead and day of energy markets that are operated by a separate entity. So they're separate functional roles. How we bundle them is a design question. Then similarly, the transmission owner owns, maintains, and operates transmission system assets. We see that in the ISO today. The 3 IOUs are participating transmission owners, as are some of the munis, as are some third-party transmission developers. They're all the owners, but the ISO is the operator. And then, of course, customers and DERs are all the network users. And I want to include in network users the idea of, say, a standalone DER. It could be storage device. It could be a combined hybrid solar plus storage without retail load. That still is part of, that still is a type of DER. And we may see more of those. And it is a customer of the network, if you like. It's using network services. So with that, let me just move to this one. And applying this idea of functional roles and actors to the power system. What you see in all these blue boxes are just different functional roles. I haven't got everything in here. And in particular, there was discussion this morning about the role of the regulators. We talked about FERC, we talked about state regulators. They're also important roles in the functioning of the power system. They're not on this diagram, but we will come back to that in future meetings. Here I've just captured the bulk generators, the energy market operator, TSO, and then the typical, the critical physical connection between the entity that's operating the balancing authority and the entity that's operating the distribution network, and they meet at these physical TD interfaces. The lines in the earlier one, when I showed a family, I didn't put connecting lines between the functional roles, but here the connecting lines are just to indicate that there's a relationship between those functional roles. In other words, a bulk generator, an entity who's operating a generating facility, has a relationship with the transmission owner because it's physically connected to that transmission owner's system. Similarly, the distribution owner and the distribution network operator have a relationship. The customer, by virtue of the interconnection process, is related, and so on. So we have these interrelations. Now, as we go to actors, here's where we start bundling functional roles together. So the IOUs today in California, they have the DNO role, that is, they're operators of the network. They have the DO role, they're also the owner and maintain the assets. They have an LSE role. They serve retail customers under bundled service. They are playing the MDMA role. They are the collectors, not for all customers, but for most, are the collectors of the meter data and the disseminators to other parties that need it. They are transmission owners that participate in the ISO, and they own a certain amount of generating capacity. So these are 6 different functional roles that the IOU as an actor is playing together today. And so as we think about, and then CAISO, similarly, it puts together the balancing authority role, which is the system operator, along with the energy market operator role. As I said, in UK and Europe, those are separate entities. In the US RTO system, they're combined. CCAs and ESPs, the retail energy service providers, they're different types of LSEs. So these are some of the actors that play different roles. When we get down to DSO, I've not put DSO on the diagram, and I've not tried to say which functional roles it plays, because that's our question. That's really the design question that we want to get into here. And so that's, there it is. And so this is just a recap basically of what we talked about, but here's sort of the outline of the concept. The functional roles are the building blocks. We describe them independent of the entity or actor that performs the role. Functions is another layer granularity down the system. And so things like supply demand balancing, forecasting, interconnection, dispatch of resources, procuring ancillary services. There's really dozens and if not hundreds of different types of functions that comprise the major functional roles. And we're not going to get into that today except to notice that they exist, that the functional role, as I've described on the previous page, isn't specific enough to say exactly, well, what does the DSO or anybody else have to do? You have to get into this next level, and that will become a topic of a future workshop. I called it maybe a DSO 201 presentation. We may get into that. The actors are the entities who participate in enabling the system performance. And then just a shorthand for functional roles and responsibilities. It's some bundle of functional roles, functions that are going to be assigned to an actor. And then to summarize, a DSO model is an assignment of these functional roles and responsibilities to the DSO entity, plus specifying how it needs to interact with all the other actors and roles. So once you create that specification, you can call that a system structure or a system architecture that lays out the roles and responsibilities and assigns them to other parties. And of course, as we said earlier, choosing a DSO model is not just about the DSO, but it has impacts on what all the other parties need to do. And I think that takes us to a good stopping place. I think it does, yeah. Rob, to you, or Matthew.
Well, Lorenzo, you did a good job making up on some time. We are about 6 minutes late for lunch, and I've noticed that the level of energy in the Q&A has fallen off. That perhaps correlates to blood sugar levels. So I want to suggest, if it's okay with you, Rob, that we go ahead and get to our break, let folks get something to eat, and we can start when we come back with a couple of the questions that came in.
Yeah, and let's go with the full, 30 minutes of the plan. So about, 107, and that might give folks some time to type in a question or two as well.
Yeah.
So we'll see everyone back at 107.
Okay.
And this line is going to stay open, right, Rob? You just want folks to stay connected?
Yes, I'm not closing the meeting. It'll just stay open.
Yep. And I will definitely not mess with anything.
Will you be pausing the recording, Rob?
I'm kind of nervous to do that. I'll think about that.
Okay.
All right, we'll see you soon.
Good luck to both of you with your technical challenges.
Seems to be working. That's good. And we'll wait for Lorenzo to get back.
I see Lorenzo.
I'm here.
Gabe, that's awesome. When you walk in like that and you have your backdrop, that was pretty nice. I don't know if others saw that.
Yeah. Looks like Jeremiah Johnson coming down from the mountains.
I just took a little lunchtime hike up to Half Dome.
Great. Should we jump into some of these questions or give folks a few more minutes?
That's a good idea. Yeah, see if we can address a few questions and then, yeah.
Awesome. Okay, so I think we have 3 good questions to work with here. Let's start with Regarding slide number 12, is it necessary for all DSO roles to be within a single entity? Or, for example, could the utilities take on some DSO role while other organizations, such as an independent planner, take on other functionality?
Yeah, I don't think there's any definitive concept that governs that. I think that's really part of the conversation we'll be having over the coming workshops.
Great. Yeah, I think you got to that in your slides. This question was posed before those slides, but functional roles and responsibilities relative to actors, I think, is a really helpful way to think about this. And part of our job is to talk about the functional roles and responsibilities separate from the actors, and then come back to who should be responsible for those things. All right. So next question. How do we quantify and characterize the expected benefits of different DSO models? And we haven't talked about benefits in particular in your presentation here yet, Lorenzo, but it does seem to me to be the other side of the same coin of why have this conversation? What are the potential needs that could be addressed by DSO?
I think that's right. We start really with what is it that we're trying to accomplish? I think this goes to Richard Coe's question as well, which I saw in the chat about where is the problem definition part of this? And it's really in steps 1 and 2 where we define what are the societal goals we're trying to accomplish and what are the system performance attributes, if you like, or behaviors, ways the system needs to function in order to accomplish those goals. We set that out at the beginning. Now, specifying the goals at a high level is one thing. We can say, well, we want it to be resilient, but then we've got to go down to a next level of granularity and talk about what exactly do we mean by resilient and how do we measure it. So I think the question being asked is a good one. And it's one that I think is a work in progress in a lot of places. I know that the CPUC's OIIP is taking up questions of trying to characterize the benefits of DERs. And I think it's some of the same benefits that we will seek with DSO models. That is, how well, if you go back to the goal that the PUC stated in the OIR to maximize the benefits of DERs, well, what are the benefits of DERs? And then how do the different DSO models succeed in delivering those benefits?
Great. Let me ask you one more just warm-up question here before folks come back from lunch and we move on.
May I ask a question?
Sure, go ahead, Gabe.
Yeah, sure, Gabe.
So I think in your presentation, you certainly identified some of the overarching, goals of the proceeding, that namely the one about, maximizing the benefits and minimizing the unintended consequences of DRs. I'm curious if you have thoughts about how the specific scope questions related to DSO address this question, sort of going back to Richard's question. How do alternative DSO models compare in their ability to plan and operate a high DR grid, unlock economic opportunity for DR and provide grid services, limit market power, reduce ratepayer costs, increase equity, and support grid resiliency while meeting state policy objectives? Now, that's a lot of goals. But
it is.
I mean, I'm just curious your opinion of that set of questions and how it relates to Richard's question. Do you think we've defined the problem statement enough, or do we need to? Richard seems to be suggesting we haven't really answered what's the problem we're seeking to solve.
Yeah, I guess. Well, in terms of Richard's question, I think he was. I can't speak for what he had in mind, but the way I read it was he was just asking how does the problem definition fit into the 4-step process that I described, and I think it's in steps 1 and 2. As to your question, whether I think it's sufficiently identified, all of the things that you listed, I think are relevant. And but I think it will be all of us getting together at the next workshop to say, have we left anything out?
Yeah.
Is there anything here that's redundant? Are there things that are less important than others? I think that's a stakeholder conversation for us to have.
Yeah, thank you. Sounds good.
Okay, well, we've got to 1:45. So Lorenzo, would you like to continue?
Okay, I'm ready to continue. Here we go. All right, this is really the last part, and it gets into really starting to apply some of these ideas and of roles and functions to different DSO models. So I want to start with a concept that I think should not be completely unfamiliar because it was raised in the GridWorks white paper, but we haven't really talked about it up to now, and that's the idea of layered architecture. Layered architecture is a DSO model design concept that we can talk about and consider. And I think it's relevant because it is a way of thinking about relationships between the different actors and the different functional roles. So what you see on the left is really not much different from the earlier diagram that I showed with these two sections of the grid being side to side. Here they're in a top-down kind of configuration, but not really intended to be different, but to highlight some different features, in particular the interfaces. So these red eggs here are the transmission distribution substations. Those are the places where the distribution grid meets the balancing authority. The unit of analysis is still the local distribution area. That is the set of all distribution facilities that are connected to a single transmission distribution interface. But then going down another layer, there's yellow eggs that are the interfaces between the distribution system and the individual users of the network. And the users of the network can be retail customers who are consumers of energy. They could also be individual DERs that are standalone, that don't have load connected at the same location, but are participating in the network. It could be a microgrid, which has internal buildings and customers, but these yellow eggs then represent the interfaces. The point of highlighting these on the diagram is to describe layered architecture in terms of its focus on the interfaces between layers. So we consider bulk power system at the top, that's being a layer. It's the transmission grid and all the bulk connected resources. And in the West, there's like 38 balancing authorities, and they all interconnect with each other and comprise the whole system. The next layer down is the distribution system, which we saw is connected through these TD interface substations. The next layer down is the customers who are the network users, and maybe there's an intermediate layer if there's a multi-customer microgrid that comprises multiple customers and DERs and buildings and so on. The ideas of layered architecture is that, pointing to the third bullet, each layer needs to manage its interfaces with the adjacent layers above and below. So in particular, the DSO operating a local distribution area, it's got to manage interfaces with the ISO at the TD substation. It's got to manage interfaces with the customers. Individual customers will have some responsibility for their interface with the distribution network. And we see that in the conversations about smart inverters and interconnection requirements that may have to do with inverter settings, for example. So there are responsibilities, but the highlight in green here, the fourth bullet down, the focus on interfaces in this purely layered model means that the operator of each layer does not need visibility or control of assets within the layer below. And this is quite a difference from how we're thinking about the system today. But what that would mean is that at the ISO level, with suitable definition to how this red egg works and what are the responsibilities of the DSO and what are the performance standards, whatever other technical requirements we want to specify over this TD interface, it is at least conceptually possible to specify it in a way that the ISO doesn't need to see visibility to any of the DERs, because the DSO is assuming so much responsibility for maintaining this interface and coordinating the DERs in a way that maintains that reliable interface. It's a conceptual bookend, if you like, but also about the interfaces is they can all allow for bidirectional flows. We're already seeing that, of course, at the yellow eggs, where resources behind the meter are feeding back energy, exporting energy onto the grid. We could also be seeing that at the bulk system interface with the DSO. Each layer can potentially island from the layer above, which adds a kind of resiliency feature that limits the propagation, say, of major system problems. Layering has then implications for who's responsible for what. So thinking about layered architecture gives us a way then to create a spectrum of DSO models. You saw this idea also in the GridWorks white paper a few months ago. I'm just adding a little bit more detail to it. So the spectrum on the left is a total TSO, transmission system operator, or you can think ISO, a fully centralized system under control of the ISO. All the way at the other end, a total DSO is a fully layered architecture or fully decentralized system. Let's talk about the total TSO first. This is intended as a concept. It's an extreme, as you'll see, but it's a kind of conceptual bookend which helps us think about how intermediate hybrid models might differ. So the total TSO says the TSO or the KISO is responsible for all DER integration activities. Now, in this extreme bookend value, bookend model, the ISO would be modeling distribution network circuits. It actually has a map of the distribution network, and when it sees DERs, it sees those DERs at their actual locations, and it mixes them all into the market optimization in some fashion, and it dispatches what is optimal, whether it's day-ahead schedules, real-time dispatch, etc. And it does so accounting for distribution grid conditions. So essentially, the TSO becomes the operator of the combined system that consists of both transmission and distribution. As I say, it's an extreme conceptual bookend, but it's useful in that perspective as one end of a spectrum. Clearly, it would require substantial functional enhancements by the TSO. I don't know of any ISO or RTO that's getting into detailed modeling of distribution systems at this point, and even contemplating that. Down at the bottom, the other end of the extreme total DSO, again, it's a conceptual extreme, but imagine that the DSO at that interface point looks like a single resource to the ISO. The ISO, all it sees is there's this interface point, there's some resource on the other side, there's a DSO who's managing that resource, making offers into the market, and the ISO would issue dispatch or a day-ahead schedule to the DSO, and the DSO then dispatches participating DERs in a way that manages its system. You can see that there is a certain simplification involved in this kind of model, even though it's extremely different from how things work today. But the simplification being the DSO is completely responsible for responding to the ISO dispatch. And it can, if distribution circuits change conditions, if there's circuit switching that needs to take place or whatever, it can redispatch resources internally in order to comply with the ISO dispatch. The ISO doesn't need to worry about specific DERs being constrained. That's the DSO's problem. Again, substantial functional enhancements, an extreme bookend. In between, there's a lot of different hybrid models. We'll illustrate some in a moment. But the hybrid notion is really some form of which is the trajectory we're on today, that the TSO models DER at the TD interfaces. And that's really the way it works for the CAISO today. When they see distributed resources, they're modeling them in the market software as if they're located at the TD interface. It doesn't see actual locations in distribution. But it still is dispatching individual resources. So it's still concerned about an individual DER or a DER aggregation. They are distinct offers that are coming into the ISO market at the TD interface. So it sees them all individually, but it sees them all as if they're at that interface. And then the DSO is responsible to manage all of those DER activities on the distribution system. And there's kind of a two-way impact that needs to be managed. One is that the operation of DERs trying to comply with an ISO dispatch is going to affect the distribution system. It could create a voltage problem or a thermal problem. And conversely, changes in grid conditions, which could be happening at any moment in real time, may suddenly constrain the ability of a DER to respond. So all of those impacts and communication about them and visibility would need to be managed by the DSO. Now, within that general concept, there's still a lot of different variations of how we might bundle roles and responsibilities, but some variation of this hybrid idea is what we're seeing in most places. So here is another version of that, just to make it a little bit more graphic. The total TSO centralized, you see everything here, all the DERs are going directly to the ISO, and the DSO is off to the side. It has some functional responsibility for maintaining reliable operation, but all the coordination with DERs is happening directly with the ISO. At the other end of the spectrum, total DSO, or the total layered architecture, here all the action on the distribution side is going through the DSO, and the DSO is the single interface with the ISO at that TD substation. In between are these variants, which is just in a very simplified version, that there's relationships that the DERs have with the distribution utility. Some of them are bidding directly into the ISO market, but they also have some coordination activities with the DSO. The DSO has coordination activities with the ISO. And again, there's various ways of implementing that, but that's sort of a common characteristic. So on the TSO side or ISO side, they're dispatching the DERs in the wholesale market, but they're modeling them at the TD interfaces, and the TSO has minimal visibility into the distribution system. It might see the resources, but it's not looking at network capacities and conditions of the actual circuits. Hybrid DSO on the DSO side, the DSO is dispatching DER perhaps for distribution grid needs and services, but it's coordinating with the TSO to ensure reliable DER wholesale transactions. And that's sort of the FERC 2222 concept. Last significant slide here, I've tried to put it all together in what I call a high-level taxonomy, but it's highly simplified. So let me walk you through this. Starting with the roles on the left, I'm only looking at three roles. The distribution owner, which I said is the entity that owns and maintains the assets. The distribution network operator, responsible for reliable operation of the network, and distribution market operator. We talked a little bit about that before lunch. There are different versions of markets that we can imagine. I'm not going to get into the details here. That will be for a future workshop. But for now, let's just say that there could be some market type transactions or market functions on distribution level that become part of the future mix. It could be from the minimum of, say, an RFP to procure DER services for substituting for a distribution upgrade, or it could be more sophisticated energy trading. The orange boxes represent which functions are getting bundled into the DSO. So here we have the total TSO at one extreme on the left, the total DSO at the other extreme on the right, and then two different versions of hybrid models that are potential models in between. Now, one thing I'll point out is that for all three of these models to the right, you see a utility column and an IDSO column. IDSO is a term that's been used in the literature going back to 2015 or 16. There were some papers written about the idea that the DSO should be independent of the entity that owns the distribution assets. And so that question was raised in the GridWorks paper as well. So what I'm distinguishing here is a DSO that bundles this DO function with the DSO, which I'm calling a utility DSO, and the independent DSO, which separates the distribution owner from the DSO, which I'm calling IDSO or independent DSO, referring back to that other literature. The interesting thing to note is that this distinction, utility versus IDSO, can be applied under each of these hybrid models and under the total DSO. You could do any of them and consider whether you want the distribution owner to be included in the DSO or separate. So that's there as one variable to consider. The idea of the hybrids, hybrid number one, you might say is kind of minimal, is that the DSO has network operator functions, but if there's any market functions layered on, we're leaving that to the TSO or the ISO. Whereas move to hybrid number two, and now the DSO still has the network operator function, but there could be market functions, some of them played by the DSO and some of them played by the TSO. So I think you might think of, well, the DSO is going to be procuring grid services that support distribution operations or that support non-wires alternatives for distribution assets, whereas the TSO might be operating the market functions that relate to participating in the wholesale markets. And that would be energy ancillary services and so on. So that's a possible hybrid design. When we get to the total DSO, of course, the total DSO is doing all of those functions, and it has this layered feature that I mentioned earlier as a characteristic of what total DSO means. The bottom line here, I just tried to provide links back to the models that were in the GridWorks paper. They laid out 6 different models, and I think this is the correspondence of the nomenclature GridWorks used to the taxonomy that I've laid out here. And the last couple of points, MDMA role, I didn't try to show here, not to say it's not important. LSE role, I didn't show here, again, not to say it's not important, but I wanted to simplify by focusing just on these 3 functional roles to illustrate the possibility of different types of DSO designs. And that's really the last substantive slide that I have. For wrap up, I've just repeated the takeaways that I stated at the beginning. Hopefully these all make a lot more sense to you now. DSO is not a well-defined thing. It's really a placeholder for where we're going in this proceeding. It's not optional that for growth of DERs, high DER, we have to upgrade functionality of the system and the system operator. We need to start with roles and functions, which are building blocks, defining them independently of the actors. And then as we formulate DSO models, we'll look at different ways of taking bundles of roles and functions and assigning them to this DSO entity and specifying how it interacts with the others. And then all important, we do have to compare them. And so the basis of comparison goes back to what did we do at the beginning? What are the goals we're trying to accomplish? What's the problem we're trying to solve? What are the performance requirements we're looking at? What are the guiding principles? All of those become criteria against which to evaluate. And then finally, this is also a repeat of the earlier slide, which just shows the 4-step process. And as we said, the next workshop, visions of objectives for a future grid, steps 1 and 2, I think that'll be a major conversation that will deal with problem statement, goals, and the performance we're looking for, and help us create these criteria that we'll use later on for evaluating alternative models. So I hope that this gives you the idea of how we're going to go about creating DSO models. Of course, this was just an introduction. So when we actually move into step 3, we'll dig in some detail to these functional roles and what they entail, and dig down into more granular specifications of what functions are required. You heard a lot about that in the utility presentations this morning. They started to give, I think, a good preview of how functional requirements change as we move to a high DER system. So we'll get into that for the sake of creating a framework for constructing DSO models. Then we'll construct the models we want to look at and begin a comparison process, and then ultimately end up with what are the preferred models that we'll recommend, or that the final report will feature in a report to the commission. And so that's really the end of my presentation. I will leave it up for now in case anybody wants to refer back to any one of the slides.
Thanks, Lorenzo. Let me give you a couple of softballs to help drive home what I think are high-level points that we want to make sure people don't miss. First of all, what is one of the most common misunderstandings about DSOs and the evaluation of different DSO models? What is the most common misunderstanding among folks who take up that question?
Well, I think there's a few things. One, I guess, I don't know if it's a misunderstanding exactly, but we have a tendency in our industry to want to jump into technical details right away. And so one point that I really wanted to get across was you need to think about what are the outcomes you're looking for? What functions does it need to perform before you get into specifying the technical details? That's one. Another, I think, is that there's an option as to, do we want a DSO or do we not want a DSO? And hopefully, from what you heard this morning from the IOUs and from my presentation, you'll see that if we are indeed moving into a high DER future, we have to do a functional upgrade. So it's not a question of whether or not, it's really just what kind. And then I think one of the other assumptions, and this may be left over from the earlier writings about independent DSOs, that some people assume that it means creating a new entity which is separate from the existing utilities. And, you know, that is certainly a possibility, but that's not really something to be assumed at this point. It's really the question, part of the design question we're looking at. So DSO really refers to this bundle of functional roles and responsibilities before you get to who's the actor that's going to play that role, who's the actor that's going to perform those functions.
Good. Thank you. And a variation on that question, you've made this presentation and variations on this presentation for coming up on 9 years now. What's the most frequently asked question you received about this content?
Wow. That's a good one. I think mostly the questions that I get, it's not one question, it's that I think people want to jump right into the technical details. You know, I think that to me, that's kind of one of the challenges, is trying to slow us down to think about goals and outcomes and performance that we're looking for, without going right to, well, what kind of a DERMS do we need? And a lot of that technical stuff. So that's kind of the most common response that I get.
Great, thank you. We got a question here from Brad Hebner. Can you play out some scenarios of different entities or types of entities that could perform the different DSO roles? Brad clarifies he understands the value of defining roles first, but it would be helpful to have a picture of different options.
Well, I don't want to I don't want to tip the balance here too much because in a way that's going to come later. But I'll refer back to this meter data management authority that we talked about back in the 1990s when we were thinking about retail side direct access. And it became a centerpiece really of some of the workshops there to say, if multiple parties need access to this data, maybe we should think about creating a separate authority whose job it is simply to collect and manage and disseminate meter data and do it in a way that observes all of the concerns about privacy and confidentiality and so on, but it's a separate entity that does that. So there may be, as we explore these ideas, reasons why we want certain functions to be spun off into a separate authority, or there may not, but I think those are the kinds of questions. In terms of assigning, I think Brad's question may be among the existing spectrum of actors who could do what. And I think I saw a question arise in the chat earlier in the day about whether CCAs could play a DSO role. And in my opinion, it's premature to try and answer that question.
Great. We had a question earlier about DSO models globally. And since that question's been posed, we've had iterative recognition that the DSO is not one thing. It can be many different things, and it depends on what functions are needed. So let me ask a variation on the question that recognizes that the DSO is not a homogeneous concept. Where have you, Lorenzo, seen the most significant changes in distribution system operations that have occurred in practice? And what precipitated those changes, and what have been the results?
Well, I think in general, and I draw on some of the things that my IOU colleagues talked about this morning, is the density of DER growth has a lot to do with it. And as you're posing your question, it triggered in my mind the idea that we may not even have one single DSO model that applies throughout all of a large utility's territory. Suppose, for example, that PG&E becomes the DSO for its service area. Well, in very densely populated areas, there may be very high penetration of DERs, and this notion of a total DSO type model where the DSO does all the coordination and is able to offer bids into the ISO may make sense. But you move to a more sparsely populated, or where there's slow DER growth, and a more modest DSO design may be more appropriate. And I know some of the work that I did over the past year with utilities in other states about compliance with FERC Order 2222. Many of them are seeing very little DER growth, with the exception of rooftop solar. But in terms of more dispatchable kinds of resources, whether it's DERs plus solar or standalone, DERs, solar plus storage, or those, very little growth. And so the idea of investing in a more capable DSO doesn't seem to be that compelling just yet. So I think the main variable really is the rapidity and the density of DER growth. I'm not sure if that answered your question, but I hope it did.
It's very helpful.
I have one question, Matthew. Would now be an okay time to ask it?
By all means, go ahead.
Okay. Lorenzo, could you go to slide 15?
Yeah.
Yeah, so I really find this slide helpful. And I was thinking about what the existing distribution operations model looks like. How is it currently done? And I wanted to ask a few questions. So for example, DO is distribution owner. So let's say that's PG&E or SDG&E or SCE. And the distribution network operator, and just tell me if I got something wrong, and I'll lead up to the question. The network operator is also one of the existing utilities. They're operating their network. And on the other side, this is the CAISO. So right now, it's the utilities operating the network. The metering data management, there is no authority, but the metering data is held with the utilities. And then my question is about where aggregators sit. So it could be a CCA, it could be a manufacturer, installer, whoever is managing a grouping of distributed energy resources and aggregating them. Where would that sit on this model if we were talking about the current system?
Okay, well, for one, a load serving entity is a type of aggregator, right? They're aggregating end use customers for the sake of procuring wholesale energy to provide to retail customers. So that's one type. And in fact, we're seeing some CCAs venture into aggregating devices behind the meter for a certain type of response. Now, I would think we would create another box here. This is called a structure diagram. We'd create another box that's called, say, DER aggregator. And so I would say, well, it's going to have a relationship with the end use customer, because if it's aggregating behind the meter resources, it has to have a relationship with the customer. It would have to have a relationship with the distribution network operator, because if it's going to be providing grid services or bidding into the wholesale market, it has to have a way of coordinating around distribution grid conditions to know if its bids are feasible, or to know if it's able to perform to its full capacity. It's going to have some relationship with the meter data management authority, because it's going to need customer meter data to do settlement with the participating customers and so on. So you would create another box that then defines, okay, what is this thing going to do that we call an aggregator, and who else does it need to talk to in some way in the system in order to be able to do its job?
So it would sit, I mentioned the DO, the DNO, the MDM or MDMA, which doesn't really exist. This box would sit somewhere below those three, above customer and energy user, and LSC is a type of aggregator. So that's kind of where it would sit if we were to add that role.
Well, and it's hard to do because now you have crisscrossing lines, but because no matter where you put it, if I were to put it, say, in the middle here in this big open space, well, it still needs to relate to the individual customer, because it's the behind the meter resources that are participating in the aggregation, but it's also going to be bidding into the bulk power market. Part of the reason why it's aggregating is to offer into the wholesale market. So there would be a link to the EMO as well as to the individual customers, and that's where the lines get complicated. So then you start needing more sophisticated software to draw the picture. But the idea is you look at
3D model. I think you need to extend the line on the Z axis.
Well, yeah, I can send you all a link to this report I worked on for the IESO in Ontario, where we made use of structure diagrams in exactly this way that spell them out in detail, and it might be informative for you all to look at. I'll send a link and you can make that available to the participants.
Good, thank you.
Anything else?
I guess while we're on this slide, maybe one last question is the EMO is clearly the CAISO in this example of the current roles, but it's really mostly about the bulk and wholesale market. So what's not on this for a future DSO would be an EMO that's distribution focused, right? I mean, is that sort of a key addition that would be explored in the future?
Yeah, I didn't put DMO, distribution market operators. It's not on the diagram.
Right.
You're right. Yep. But again, you can imagine, well, which entities does it need to interact with? And that would come from well, what kind of market is it going to run? So we'd start, what do you want the DMO to do? Do you want it to run, say, RFP solicitations for non-wires alternatives? Do you want it to run kind of a bidding market for real-time grid services like congestion relief and voltage management? Do you want it to run an energy market for transacting energy surpluses? So you'd start there. What kind of market do we want it to run? And then you'd go, well, which entities then does it need to have interactions with in order to be able to perform that function?
I think that's all the questions we got in the Q&A, and it's the time we had allotted for this session. So I think on behalf of everyone, I want to thank both Lorenzo and our presenters from this morning for a significant amount of educational resource. And I also want to just put in a plug that later in the meeting, during item 8 on the agenda, we're going to have an open conversation about what we've heard today and about where it leads us. And one of the questions I'll be posing during that open discussion is, what questions are you taking from this workshop with you as you leave? What still remains an open question for you, or where do you want to dig deeper into some of these things to really understand the material as best you can for participation? And those questions that you give us that still need addressing will be part of our homework going forward. So I just want to plant the seed now for all the participants to be thinking about, based on what you've heard here, what still remains an open question? What terms do you need to find? What ideas do you want to get your head around better? Or what would you like to hear more about? And we'll give you a chance to give us that guidance at the end of the workshop.
Great, thank you, Matthew. And let's go ahead and take a quick break. I think it's a good breaking point. So we're turning at 1:55. And before we break, I'll just note slight change in item number 7. We will have a question answer session following that. And Matthew, as he has been, will be facilitating Q&A there. And I do plan to get through all the slides. I'll be presenting because it all fits together, the work plan, the outreach plan, which I'm excited to present. And so we'll try to get through all the slides, followed by QA, and then section 8 as explained. So I'll see you all in 5 minutes, 1:55.
Rob, I don't know how to unshare. I think maybe you can just turn me off.
Oh yeah, that's a good point. I'll just change your role back to, I'll change myself back to the presenter.
Yeah.
And I'll share my slides, which shouldn't do that trick.
Okay.
All right, thank you, Lorenzo.
Sure thing.
Hey, what's up?
Hey, Rob. On mute.
Okay, quick break. Let's go by so fast. So we're back, and I hope everyone is seeing my slides. I believe you are. Starting a section here on the new outreach plan and how ongoing education will fit into that, as well as how existing plans for community engagement will tie in. So I hope to make it clear how all of it will tie together with our new plans for Track 2 distribution system operations outreach. So there are, make sure I'm off mute. Yep, I am. There are 2 tracks, actually 3 tracks in the high DER proceeding, but we're not talking about the third one today. But 2 tracks, the first 2, one focused really on distribution planning and improving that process. And then the other track focused on distribution system operations. Now, in the scoping ruling, which was issued last November, there was already identified, based on comments on the order instituting rulemaking, the need for a community engagement needs assessment to ask the question, what do communities want and need from distribution planning? Which we heard as being a separate activity. I think Mark from now SCE explained that that's like planning to use a car. You know, what's part of the car? You know, building the car. You know, setting it up so that the operator can then drive the car. 2 separate activities, 2 separate tracks. And we have an existing outreach plan that I'll be describing for Track 1. And we've now added to that plan that's in a way that is responsive to comments we received on the workshop for Track 2 we held on May 3rd. So the Track 1 community engagement needs assessment has a number of goals, and specifically to be responsive to communities' evolving needs from the power grid. As I said, we want to determine what communities want and need that may be different than what they're already receiving from the utilities who conduct outreach already. And for example, on microgrids and resiliency planning on an annual basis. Now, the scope of the needs assessment to be done has not yet been defined, and the scoping ruling envisions that developing that scope of work for a future consultant to do a deep dive with communities and what they want and need from distribution planning. That scope of work would be developed through a process, including a workshop, which we're planning for November, and then a staff proposal, and then which includes a proposal for the scope of work. We take comments on it, and then finally a decision would adopt the final scope of work, including a funding amount for consulting team to be hired. Now for track 2, what I'm presenting today is an additional outreach plan. And just so we talked about, we had our first white paper that we delivered on May 3rd, and that was the kickoff of our technical workshop series, which we have put on pause based on feedback so that we could increase the involvement of non-traditional stakeholders, meaning not just the utility companies or larger energy providers like community choice aggregators, or even maybe the larger cities, but non-traditional voices that we don't normally have participating in our proceeding because it costs, it takes time and money and effort to participate. And so we developed this additional outreach plan to support track 2 specifically and the development of the future grid study, which is what the work from track 2 will culminate in, which is a draft study which evaluates various distribution system operator models that may be appropriate for California, and then documents it, and we take a robust amount of comment on it from all voices, all parties, all stakeholders that we can reach. And then that final study would be adopted by the commission and likely will lead to a successor proceeding on maybe some specific prioritized models, as Lorenzo had kind of previewed for us in his presentation. So and maybe I'll stop there for a moment and just give Gabe the opportunity to add anything that I might have overlooked, if there is something you'd like to add.
No, this is great. I mean, just that we are trying to supplement the methods of getting stakeholder feedback into the record and going beyond traditional methods. So traditional methods are workshops, are comment periods, and we're going to try some different methods to try to increase the involvement of other parties that may have not participated as much in the past. It doesn't mean we're, considering less those that are participating. We just want to add more voices to the mix.
Thank you. So the plan is, as proposed, is organized around 3 principles. We see the need to educate on highly technical grid operations topics, as an example today, both on current grid operations, distribution system operations, and potential future alternative versions. We had a workshop on July 29th, I believe it was in July, it may have been 26th, on data portals, and included a session there on distribution planning to help provide education. And I chatted out the date, September 19th, where we have had an annual, what we call a primer on grid needs assessment filings from the utilities that are annual. I'm not planning on getting into detail on the grid needs assessments, but that primer we're expecting to include more distribution planning education. So today focused on operations, that primer on distribution planning. So including education we see as being very important because we want to ensure all voices that want to participate are prepared. Now, beyond education, we've, based on feedback and understand the need to also listen. It's not just a one-way street on education. To win, what are the wants and needs of various communities and all stakeholders? And then finally, since we have a scoping ruling and we have specific scoping questions, we will have a need to focus back so we can address those technical questions. And then the idea is to have this be a cycle. And so as needed, as technical issues come up and we're not getting the engagement we need, we will educate and listen and refocus again. So why listening sessions? That listening sessions is something we're planning as in the coming months. And the primary goal is to engage with tribes and community-based organizations, local governments, to understand and document their specific needs and perspectives regarding alternative DSO models or the status quo model. And, you know, conducting a series, before we conduct this series of highly technical workshops. And we value the input of all stakeholders, but simply want to make sure that those who don't typically participate can be heard. And as Gabe mentioned, this would complement more traditional feedback methods, you know, formal comments put on the record, as we have those comments being due August 31st for this outreach plan. But we want to enable diverse voices and perspectives, especially on as we develop this future grid study, and then once we developed it, on its review. The listening sessions we're hoping to set up would be in September and October, so that's coming right around the corner. Hopefully, we could set up some sessions by late September and into October. We're initially planning on 8 sessions, and GridWorks would help facilitate, as well as other members of our consultant team, as well as Gabe and myself, and the CEC would participate in the sessions. We're planning sessions with a session with tribes, rural local governments, and then with urban and suburban local governments, as well as CBOs, community-based organizations. We would prepare a summary of all the sessions, and those summaries of each specific session would be provided to participants so they could review it. And finally, we culminate all the session summaries into a single document that would be shared for comment to the high DER proceeding service list. And then separately, to ensure tribes can engage, the tribal advisor may provide comments and details to tribal participants as needed. So we've engaged a fairly broad team already to support the listening session effort. That includes members of the CPUC's business and community outreach staff, CEC outreach staff, tribal advisors from both agencies, as well as our consulting team and the high DER staff, Gabe and myself. And we hope that by the end of August, we have identified some potential participants. As I said, GridWorks would lead engagement and logistical coordination and facilitation, and details on dates and the platform for holding these sessions and the agenda would come later. And if interested in being part of these sessions, or if you have suggested participants, we're hoping you would email Matthew Tisdale and Kate Griffith so that they can help coordinate, and they'll be working in close coordination with us as well. Before I go to the technical workshop series, I'll just pause and see if, Gabe, is there anything you'd like to add so far?
Yeah, I mean, I may be repeating it, but I just want to make sure we are being clear and reassuring to all stakeholders that while we may not speak to every stakeholder in a listening session, it doesn't mean that we're not listening to those that continue to participate in the traditional methods. Again, we're just trying to try different approaches here in response to feedback that, different stakeholders are differently situated and sometimes respond to different methods of engagement. And so, hope everyone understands that as we both said, we care about the inputs of all stakeholders, but we are trying some new approaches here in response to feedback that seem to be needed to try to bridge some of the gaps in participation. So hopefully that's coming through, and we'll hear it in your comments when we look for those comments at the end of the month. But thanks again.
So following the listening sessions, assuming the proposal for outreach is approved and implemented, we plan to return to the technical workshop series that was defined initially in the white paper issued this spring. We'd start in Q1 2023, and we would have a series of workshops, as Lorenzo alluded to. The visions and objectives workshop for a future grid is number one. Operations needed for a future grid, the gap assessment to see what additional data is going to be needed for the analysis. We present and socialize various distribution system operator model proposals, and then identify barriers and actions and trade-offs. And then finally, a report would be prepared, a draft report. And that draft report is something we want to make sure, especially, is widely issued for comment in the state. And that's where the new consultant we hope to hire under track one, that scope of work we believe could include facilitating robust feedback on this draft report. We want to ensure that all the presentations and documents developed throughout the technical workshop series would be included in the proceeding record. And in fact, following each workshop, formal comments would be requested, and that record would be developed along the way. Another option would have been to put all of the presentations onto the record with the draft study, but we're proposing to do it along the way instead. We expect the future grid study would be issued in a few months following the 5th workshop. Hopefully that would still be in 2023. And I just want to reiterate that we expect it's likely that a successor proceeding and potential legislative action may be identified during the review process. And there may be topics that require further information for further study, and those would be identified. So we're not necessarily going to identify a preferred DSO model. In fact, I expect we won't be, but maybe several DSO models that may have the most potential for application to California. So as I mentioned already, this is where track one and track two unite. On outreach, we want to ensure robust comments are received. We propose that the outreach already scoped and planned to be developed for track one be coordinated with track two, and that scope of work for additional consultant include reaching out to communities to educate, to listen, and to focus so that we can get comments directly applicable to the evaluation of various DSO models, the evaluation and definition of them. And again, the scope of work for that additional outreach would need to be approved in a decision within track one of the proceeding. That's because of the funding needs. We already plan to have an en banc to evaluate the draft study and get feedback from international experts and other stakeholders on the study. With an en banc would have all 5 commissioners present and getting their feedback as well. So that would be planned as per the scoping ruling once the draft study has been issued. And then following that en banc, we would likely update the draft study and presenting a final version of it for adoption. The adopting decision may further alter that study, and if so, we would further, finalize the final version of the future grid study. So we have a list of questions to guide comments on this outreach plan. These are the 5 questions that were included in the August 12th ruling. We have a comment due date of August 31st, which is coming up soon, but then reply comments due on September 9th. The questions are what additional steps or actions should be added to the draft Track 2 outreach plan. Are there Track 2 outreach plan areas that need more emphasis or additions? What unique Track 2 issues should be considered for tribal, rural, or disadvantaged communities? What unique Track 2 issues should be considered for local governments? And what information should the CPU seek from listening session participants? What questions should the CPUC pose to those participants? We would then, after review of the comments provided, both initial comments and replies, release a final version of the outreach plan, which will be adopted, I believe, by ruling. So that's the updated outreach plan. I want to show fairly quickly how the technical sessions would then fit in to the various work streams of all 3 tracks for the proceeding. I'll recognize some of the text is going to look pretty small, but with access to these slides, you'll be able to zoom in and I think find the diagrams useful. The first slide is just a snapshot of where we are currently through this year. You may be able to read the Future Grid Study Education and Outreach Workshop. That's where we are today here. And we're planning to conduct the listening sessions. I'll point out, this is another it's worth noting the community engagement needs assessment scope of work for track 1. Track 1 is shown in blue. We're planning to hold in November following the listening sessions. We think the listening sessions will be helpful, very helpful in developing that scope of work for community engagement related to track 1. These slides include an updated listing of all the work for all the tracks for this proceeding, or most of the work. There may be a few things missing, but at least the high level listing. Hopefully these slides will be helpful. This is the full timeline for the proceeding. And in green, you see, well, I can help you see it a little bit if here, I'll zoom in a bit using thought I could zoom in. Here we go. So you see here we are today. We put a check mark on this workshop. Looking at Future Grid Study Workshop number 1 of 5 future study workshops to begin roughly possibly February timeframe. And then spacing out with the 2nd, the 3rd, the 4th, and the 5th workshops, technical workshops. As we go, we're going to be mindful of the technical complexity and need for future other voices. And again, revisiting the educate, listen, and focus concepts and principles as we go through this series. And especially with the draft Future Grid Study release, assuming we get that additional consultant support, getting robust and meaningful engagement statewide in utility service territories to get feedback on and review of this draft Future Grid Study. Okay, final listing of all the different work, and then I'll pause here for questions and comments.
Great, thank you, Rob. We've got a collection of questions coming in through the Q&A. Invite folks participating to add others. And just a friendly reminder that you'll have the opportunity to comment on the record August 31st on this entire plan. So if there's information you need here to inform those comments, that's especially important to get here, to get on the table here. So first question, how will the educational piece presented earlier by the utilities be used for outreach? And are there more digestible ways to present this information other than just slides? Do you all have any plans or specifics about how the educational materials might be made available to potential participants in the listening session that we want to talk about here?
Yeah, my thoughts are, well, first of all, the link and recording will be made available from today, as well as the slides. I think the listening sessions would benefit from some handouts. And depending on the questions we ultimately want to ask, I'm imagining those handouts would be about distribution planning, distribution operations, grid, distribution system operation models, and that information could draw directly from those slides.
For my part, as somebody who'll be contributing to the organization of those listening sessions, I would say if there's any other suggestions or ideas on how to make these materials as accessible as possible to those people, we welcome those ideas here in your comments, offline, whatever's easy for you. Okay, next question. What are the plans to provide financial support for CBOs and others for participating in and providing feedback during the listening session? And Gabe has responded, funding for CBOs is not part of the proposal, but if you think that is important, you could include in your feedback in the comments on the Track 2 outreach plan. Anything else to say on this front?
I'll just mention it's not a rate-making proceeding. And so developing, funds for that effort is not considered, my understanding is it's not considered to be in scope. Sorry, Gabe, I may have cut you off.
Yeah, I mean, that and just, I mean, we came up with this plan based on our independent view. We are staff, we are not the commission. Commission makes decisions, staff makes, analysis, does recommendations, and provides facilitation of conversations to get input from parties from the public. So that's what we're doing today. And so, we want to give you the opportunity to make your voice heard. If that's something you feel is strongly important to you, we'd like to hear that in your comments. But, it's up to the commission to make that call.
Just to reemphasize, we know and we've heard that a lot of community-based organizations have raised the issue regarding funding. It's been raised in the DATAG group, and that's something that the commission is closely looking at. We're looking at a CBO pilot project, looking at funding in the disconnections proceeding. As Rob said, this is not a rate-setting proceeding, and we're not looking specifically in scope at the moment to do CBO funding for this effort, but we do definitely want to hear in the comments and hear what you have to say and provide as much information as possible about why that would be helpful in looking at the long-term distribution planning to be able to have support if you think that that's something we need to be looking at. Again, just reiterating what Gabe and Rob said, to include that in your comments. But at this time, we're trying to frame what the process for the outreach will look like, and that outreach does not limit what you're able to comment on as far as how we proceed and what would be the most effective way to get the information we're looking for.
Great, thank you for that response. Next question. Regarding the outreach slides, this is a bullet point level summary and mainly process focused rather than an outreach plan. Is there any substantive documentation of how participants are being identified and recruited, how these meetings will be structured and facilitated, what sort of commitment, activities, outcomes are expected from participants, how this will be effectively communicated ahead of time, etc.? It will be difficult to provide substantive comments based on what is being provided here. So I think the question embedded there is there any expected additional information coming out about this outreach effort that folks can digest in providing feedback?
Yeah, I mean, the plan is what was in the slides, as well as discussed in the ruling. We acknowledge that, yes, a plan could be longer and more detailed, but this is what we have put forward, and we would welcome any input you have on how to carry it out successfully. I mean, this is really an effort, an exercise in, collaboration here. So we're open to your ideas and thoughts and welcome suggestions that would make it more effective. We're very much looking for that. And, we're going to do our best to carry out the plan as described in this document. But if there are additional things you think are needed, some of the questions kind of point to that, but also you could comment on it. So we welcome your input.
Yeah, I will add that from GridWorks' point of view in implementing and leading some of the listening sessions, we'll definitely be putting pen to paper to try to document it, if only for our own internal management, how this gets organized and how it gets implemented and what questions are asked and how are they documented. And if there are folks who have an interest in contributing ideas and perspective to how we do that, our job here is to be informed about that perspective and to be guided by it. So we welcome that engagement. It's not something that we expect to be a formal review process, but there's certainly opportunities to make substantive contributions, and those would be appreciated. The next question is the intent for track 2 listening sessions with local governments to present information stated today and then give local agencies a chance to respond where they have questions or concerns about how modernization of the grid may impact their operations. That feedback may also be useful for track 1 consultant report.
And my thought on that is, as we schedule the listening sessions, it will be interesting to hear what interested participants would like as a primer to ensure that session is as effective as possible. And so I think I'm not currently planning on, having a full-scale workshop like we did today for each session, but I think priming those sessions so that they can be effective is an important thing to do. So priming with the education piece before listening.
Yeah, I'll again reiterate that there's an opportunity here for folks who have expertise or experience in priming that way to further the cause by providing that perspective, and it's welcome.
Yeah, and I'll just add that the overarching purpose of the listening sessions is to hear feedback on the distribution system operator track of activities and how it's being carried out and how we can incorporate their views as to desired outcomes, desired goals, desired functions, desired roles, that kind of thing. But also just understanding their perspective on the needs of the energy grid and the communities. And then in the questions themselves that we're asking for feedback on, we are asking you, the stakeholders, what questions you think we should be asking to the participants in these listening sessions. So we have some ideas, but we certainly could benefit from additional input.
Great. I'm going to keep us moving here. We got a lot of great questions coming in. Next question is, the DSO model discussion is, of course, extremely important, but enormous amount of work will still be needed needed to be done to link the issues that communities talk about on the ground to the implications of various DSO models. For example, many under-resourced communities are interested in having community solar built to support renters. There are many current barriers to that, including regulatory, financial, logistical, grid interconnect capacity, etc. How would a given choice of DSO model impact those barriers? It goes on to say tangible examples should be prepared for the education component of the outreach workshops that link already expressed priorities of underserved communities to the operation of the distribution grid.
That is, I'll just start off. I mean, there's a lot in there. I think we're expecting to learn quite a bit from our initial listening session outreach to help address those questions, to help develop those tangible examples. We're doing something new. And, you know, the other examples, the white paper provided from the UK, from Australia, from New York, they spent a lot of time already looking at different ways of operating the distribution grid and kind of landed at status quo because it is so complex. And because all voices weren't engaged, and I'm not saying I tracked all of those. This is my reading of basically from the work paper. So I'm hoping Matthew's agreeing with what I'm saying and my own research. But, you know, we're expecting to pull off something here that I don't think has really been pulled off before, at least not in California.
Yeah, I'll chime in on this question. It's a very thoughtful question. Appreciate it. I think that, you know, at least my perspective and, you know, maybe many of our perspective is we will enter into the listening sessions really to try to meet people where they are and listen to what their concerns are. Now, if we already knew which models of DSO affect which concerns of local communities, I think we'd be a lot farther in this process than we are, but that is the purpose of the process. So we have to start somewhere, and this is where we're going to try to start. You know, the hope and the goal is to bring people along on the journey of all the steps of exploration of DSO and how they would affect a community. But in order to do that, we think, you know, some education is necessary and some engagement to try to gain their interest and participation. But so I don't think we'll be able to give them a comparison of DSO models and how they would affect different questions, but we will certainly listen to what their interests are and goals, and whether they articulate it as a DSO goal or not, we will try to capture it and record it and make it available, you know, to the proceeding. So I hope that's helpful to your question, which I thought was very, very insightful question.
Right, and I'll just, at the risk of stretching out our schedule a little bit here, because I think this is important, I'll add that, you know, within the question is a bit of a chicken and an egg, right? You want the communities to guide what DSO development is, but you also want the DSO development to be, the usefulness of that to the community's concerns to be well understood. To me, what's strong in what's being presented today from staff is that the community engagement is iterative. The listening sessions that are coming up very soon in September and October aren't the last community engagement that's intended or expected here. They're really, I think, aiming more to just get grounded in the wishes of this community. And then to have, at the end, the future grid study be brought back to community engagement phase and asked again, okay, now here's what we have on the table. Here's what maybe the implications for communities of what options are on the table. What do you think about that as well? So I like to think of it as an iterative community engagement, and hopefully that will help us deal with the chicken and an egg problem here. Lots of questions, so moving us along. We have a question. Is it possible to revise the comment deadlines so that the DAC advisory group can provide feedback? This would require waiting for the DAC advisory group on September 16th.
So I'll take and I know Judge Hines is on the call, and I think this is a procedural question. The ruling established dates, and I believe you could motion to the service list a request for an extension. I believe that's how this would be handled procedurally.
And this is Judge Himes. Can you hear me?
Yes.
Okay. Hi, everyone. Actually, a motion isn't necessary, just an email requesting an extension of time, but that email would need to be sent to the entire service list.
Thank you, Judge Hines.
Great. Next question. Will listening sessions be virtual, even for hard to reach communities?
I mean, yes, I think we're thinking about the right platform to use for virtual meetings, in this for listening sessions specifically. But yes, a virtual option is our plan.
I read the question to be asking, if the community is hard to reach virtually, is there an alternative to reaching them virtually?
Yeah, so I think for these listening sessions coming up, our expectation is that they would be virtual. However, when we look at a new consulting team, the possibility of that developing that scope of work and then marrying up of track 1 and track 2, so that we can get that robust feedback on the draft future grid study, I would expect that scope of work could include something beyond virtual. That we're going to the stakeholders instead of having them find internet access and come to us.
Great. Keeping us moving, what will be the main questions of the listening sessions? What foundational knowledge are you expecting folks who participate to have?
So I think we want to share the presentation link from today, the recording and the slide decks and some handouts. We're not expecting any foundational knowledge beyond this resource, though we can't guarantee that people will listen to it if they aren't here today, but we will certainly offer it. But I mean, as I said before, we will meet the participants where they are, and if depending on the level of knowledge, if they want to go into the kind of concepts we talked about today, we'll be ready to have that conversation. If it needs to go in a different direction, we will go that direction. We'll try to make it digestible because it may be technically complex, but we're trying to create this in a way that would be approachable.
And I'll just add to that one of the questions parties are invited to comment on is what should be the questions posed during these listening sessions.
Right.
We have some notions, but we don't want to tip the scales in the wrong direction. We would like to be better informed about what questions should be asked, and that's why it's one of the things that's available for commenting. And I hope folks will take that option up because it would be really helpful. Let's see, next question. How does outreach to educate on the DSO match with Dr. Kristoff's recommendations for DSO models to integrate community needs and the CC's point to achieve community benefits?
I mean, I think they're aligned. I think we share the same goals.
And I think we'll be learning about specific community needs as we conduct listening sessions, as we develop that future grid study. That's part of the journey we're going to take with stakeholders in the state is learning what is the best approach, or what are some of the best approaches for distribution system operations, and then documenting those findings.
There's a couple questions coming in that aren't exactly community engagement related, so I'm going to hold those and hope we can come back to them in a minute and get through a few more community engagement questions before we take a break. Next question was, can you discuss how you will balance going to communities for feedback on track 2 and track 1 when they are on different timelines and different topics, but will likely overlap in some ways as far as community needs?
Yeah, so when you look at our schedule, I thought long and hard about this one. It's been sort of my challenge all along is to how to marry this up at this stage of the proceeding, given all the work we're trying to get done. And if we can, get the scope of work agreed on and approved, get a consultant hired, that really will likely put us well into 2023 by the time that occurs. And our plan is to have started the technical workshop series early in 2023. And so by the time we have a new team, hopefully we'll line up with the time we have a draft future grid study. And then that scope of work will include the widespread dissemination, education, listening, and focusing to get, a review and comments, robust comments on that draft future grid study. So that's track 1 and track 2 marry up with the draft future grid study is our thinking.
Okay, thank you, Rob. Will the consultants be responsible for priming participants? I assume this means in the listening sessions. Is there a statewide strategy to recruit a diverse group of participants? Are there efforts being launched in underrepresented areas like South LA, Central Valley, IE? Question.
So we mentioned the various outreach groups at our agencies, including tribal advisors. And, our intent is to get a diverse group, but the state is very large. And so I think for this initial effort, we're going to do our best to reach out to non-traditional stakeholders. Some may be on vacation that would otherwise rather participate. There could be various reasons why we can't capture the input from everyone who would like to participate, but we're going to do our best to ensure we're hearing from a broad range of diverse groups.
And I think you spoke to this a little bit in your response just now, Rob, and also in your slides, but let's be sure we reiterate and be clear here. What will the outreach effort look like to inform communities about the listening sessions?
Well, it's going to be a bit grassroots. I mean, it's going to be phone calls and emails, and we have lists of both agencies have been developing lists of to conduct outreach, to disseminate emails to make specific calls to various leaders of different groups. And we're drawing on the lists of the Energy Commission and the Utilities Commission from their outreach teams to do our outreach and make invites and schedule these listening sessions.
Great. I think grassroots is a good way to describe it. We have a lot of folks fanning out to try to spread the word about this opportunity. For GridWorks' part, we've been engaging with participants in this proceeding and asking them what can you contribute to this in terms of spreading the word and helping us find folks who can contribute to these listening sessions. And understand there's probably a lot more that can be done, and welcome their contributions and suggestions of folks who are involved here toward that end?
Yeah, I would encourage participants today to help us. You know, we have a team. We're going to go into this full force, but everybody can help in a grassroots effort to spread the word.
Okay, great. Next question. Will this group, and by that I assume is the gathered people here in this proceeding, these parties, have input not only on the scope of work for the consultant that's hired under track 1, but also the criteria for being a consultant?
Yeah, with the scope of work, you would want to have a team that has a minimum level of competence. And I would imagine that that staff proposal we'll be developing could identify those things. So I would be interested in getting that feedback when we get to this point in November of holding that workshop to develop, you know, to get initial comments on that scope of work and criteria for an effective team.
Great. A lot of good questions here. So thank you for allowing us to stretch the schedule and clear up as much of this as we can. Let's take a couple more. Are planning issues off the table for the listening sessions? Many communities might want to talk about decision-making around facility siting, avoiding infrastructure expansion and related topics. How do we get smart grid infrastructure in underserved communities and avoid unwanted infrastructure? We run the risk of failing to get input or talk about synergies if we put too many walls between tracks.
I would say on at least this first round of listening sessions, the intent is to get input into the future grid study track. But as Rob said, there could be future rounds that also try to engage around the community needs assessment for distribution planning. You know, that said, like, we will listen to what people are interested in talking about, and they may be more interested in talking about facility siting than future grid, you know, DSO. If that's the case, we'll listen. But we'll at least have the intention of engaging on the future grid study, but we'll be open to hearing what they want to talk about.
Yeah, I see it as focusing being sort of the last piece of the cycle. You know, we're educating, we're listening to whatever it is that's on their mind regarding the electric grid and energy and resilience, whatever it is. And then coming back with, okay, this is what we're trying to do in track 2, how it differs from track 1. So it's a cycle that we repeat, and I wouldn't want to focus too soon. We want to listen first.
Great. And a couple more questions, and maybe some of these might be something we want to think about or try to include in our plans as we develop. But how will long-term community engagement be ensured after the listening sessions? We talked and gave some information about what would happen iteratively within this proceeding, but I read the question to be thinking about how could this effort be a springboard to longer-term community engagement that serves us further down the road. Do you all want to respond to that or just take it as a suggestion?
Well, I mean, I think we did partially address this by when we talked about how we could. I think the goal here is to increase community engagement and involvement in the proceeding, and if that results in people attending future workshops, that's great. We'll get more input. But if the only time we hear from them is in a listening session, then we'll get the input we can get. But we may do additional listening sessions at different stages of the proceeding. So, I mean, we're going to keep trying to get more input. It looks like Commissioner Houck is joining us. So I'll turn it to you.
Yeah, I just wanted to add that, yes, hopefully we will get some really positive experiences out of these listening sessions, learn more about how we should and could be doing community engagement, and that can carry over to what we're doing as a commission. Also, as we're looking at more distributed energy resources on the system, it's going to be helpful to have that community engagement as folks in the community are going to be having to possibly think differently about how they're using energy, and they're going to be contributing to this effort, whether it's storage or solar or electric vehicles, participating in energy efficiency and demand response programs and load flexibility. That continued dialogue is just going to be important to successfully looking at how we're going to make this leap into more distributed energy resources.
Thank you, Commissioner.
I would say, Matthew, so we are running a bit long. How would you feel, and Gabe and the team, about wrapping up around 2:50, taking, a few minutes and then coming back for section 8? So maybe wrapping up this Q&A session, around 2:50. So maybe 2 more questions.
Yeah, that's great. You've been on the hot seat for a while now. We want to give you a break, and so let's take 1 more question, and then just to reiterate for participants, we're having an open discussion following the break, so more of these issues can be raised at that time. Let's see, last question. How are disadvantaged and hard to reach communities being prioritized for engagement?
Well, the listening sessions are focused on reaching those communities, and as opposed to traditional stakeholders who are typically participate in proceedings at the commission. And so that's the goal of our this special outreach, is really to engage those communities. And I'll just answer the next question from Tyler as well. It's that we are planning on presenting a listening session summary of everything we've learned, and putting that on the record.
Great. All right. Well, let's take a break, and want to acknowledge that this is a work in progress, that the plan is being put forward for feedback, and the comments are invited and encouraged on the 31st, and then again, reply comments on the 9th. As I think staff and the commissioner and I have reiterated here a couple times, we'd love to have your good ideas on how to make this stronger and better. And that's what the purpose of the workshop and the comment period is for. So let's take a 5-minute break, and then we'll come back for open discussion. See you at 2:55.
Okay, Matthew, so I've got us set up for the right slides here. And I think we could move it towards our discussion and attendee feedback section. Did you want to start with this slide here?
Yep, perfect. So we have 3 objectives for this discussion. The first is to celebrate and acknowledge all the information that was exchanged today. To accomplish that, we're going to ask you, what is one new thing you learned in today's workshop? And we'll make a collection of those. Our second objective is to grab your suggestions and to take your suggestions as homework as to where we go from here. So we're asking, what is one suggestion you would offer your colleagues? And I want to emphasize here that the Energy Division, the CPUC, and the consulting team helping them is open to those suggestions, but you can also offer them to one another. Lastly, we're trying to figure out what do we need to do next in terms of educational opportunities for folks participating in this process. So to try to uncover that, we're going to ask, what is one question you'll take with you following today's workshop? Next slide, please, Rob. So the way you'll engage in this is, first of all, to navigate in your browser to Slido. And I've included the Slido link that you need to click on within the chat bar. So take a minute and click on that link, and hopefully you won't have any trouble opening up. It can be very easy, usually is. After that, I'll lead you through the three questions and give you a chance to provide some input through the Slido platform. And we'll come back after we have worked our way through those 3 questions on the Slido platform and probably have about 20 minutes for open discussion, at which time, if you have something to add, we'll ask you to raise your hand and we can unmute you to share your perspective with us over the WebEx platform. And then lastly, following the workshop, there will be more opportunities, as we mentioned earlier, for you to file comments as well. So I see some participants beginning to drop into the Slido platform. Rob, if you don't mind, give me the power to share my screen.
Yes, I'll make you the presenter.
All right. I am now the presenter. Now you should be able to share my screen. And if anybody had trouble with the link, or maybe you're on your phone, if you can see my screen, there's a QR code that you can grab. And you could also just go to slido.com and enter the numbers 3823757, 3823757, and you can participate via your mobile device. So we'll take, let's just take our time. It's been a lot of information and a lot of compressed discussion today. I want to give this question about 4 or 5 minutes to let it sit and see what folks are taking away. What is one new thing you learned at today's workshop?
I know, Matthew, it's nice as you are on the website under the polls tab, I guess you would call it, you're able to see everyone's responses as well. So it's showing on your screen, but also on my internet browser.
We'll just give this one more minute. Okay, a lot of nice compliments for the presenters on the material that was presented. Clearly, folks took a lot away from that. A lot of interesting perspective on the complexity and challenge of understanding, deliberating, evaluating DSO models, and a lot of important input on how one can understand and help other people understand these models. We'll be able to come back to these and use these as themes in our open discussion, but I'm going to move on to the next poll, and thank you all for the input here. So the next question is, based on your experience here, what you've learned, what is one suggestion you would offer your colleagues? At the end of the day, we are in this boat together. What's one suggestion you would offer your colleagues?
Matthew, by colleagues, you mean at work or stakeholders or both?
Anybody who might be involved in this conversation. I made it broad because I don't want all the suggestions necessarily to be CPUC focused as usual. There's often good ideas that we can share with one another rather than just sending them all to the CPUC and expecting you all to solve all our problems. We still have about 5 folks contributing, so I'm going to give this maybe 2 more minutes, and then we'll move on to the next poll question. Okay, great. It looks like we've reached stasis and input on this question. Some really strong and useful and welcome suggestions on community engagement, recognition of the need to provide financial support to the participants in that process, recognition of the need to keep their needs front and center, recognition of the time it takes to do that and the challenge that we're taking on in doing that. Also, good recognition in that I liked the comment about, we're all in this together, and thinking creatively about how to move forward. These are really very valuable suggestions, and they are well taken. The next bit here will be the final question, and that is, what is one question you'll take with you following this workshop? And let me reemphasize that I think our attitude on behalf of the commission is that this is just the first step in a long educational process that we're going to be going through with you. We want to make sure that the next steps that we take are informed by questions that you still have as outstanding. And we will take these questions that you're leaving with us as sort of items on our to-do list that need to be followed up on and filled in. So please take 5 minutes and let us know what is one question you'll take with you following this workshop. Okay, looks like we're winding down. We'll give this one more minute. Okay, great. Thank you all for the input here. I'll just observe based on my quick skim that there's a few technical questions, but mostly the questions here are about how does this process work? How does it be successful? How are you going to do it? How can I contribute to your success? I think that's a really important trend to be aware of and to acknowledge here within the context. I also want to note that there's a lot of interest here in the listening sessions, near-term decisions that are going to have to be made about the listening sessions. How are those decisions going to be made and executed? So there's some questions here from parties that are inform very near-term next steps of this process. There's also some things that are sort of longer term. What does success look like in the long run? So there's a lot to work with here, and again, I really appreciate the input. I hope you all find it helpful in looking at it. I was going to say that kind of when I lie in bed at night and I'm wondering what my workday is going to be like tomorrow, bubbles like this with these kind of questions percolating up in my mind is a little bit what it feels like in my mind. So it's nice to see it on the screen because, I'm not dealing with this alone. All you are dealing with it as well. So I'm going to stop my screen share. And this is the time we have set aside for open discussion. And let's see, how much time do we have left?
I was thinking about 5 minutes, and then we turn to closing remarks with Commissioner Houck.
Okay, let's start with 5 minutes, and if things are moving quickly, maybe we'll be graced with another 5 minutes. If you have a comment or a question that stems from your input on these 3 questions or from your experience here today, I want to invite you to raise your hand, and we will work within the confines of WebEx with Rob's help to open the mic for you. I'm not seeing any hands, but I'm not sure if I would see any hands with my permissions.
Yeah, I'm looking as well. I hope you would, but I'm not seeing any hands yet either. And you could chat to us if you're having issues. And then I can unmute you.
Has been a long day, but it's usually people like an open mic.
I do see a hand from Roger Lynn is up.
Thanks, Commissioner. I can't see that at all. So if you've got your hand up and we don't see it.
And Roger, I just unmuted you, Roger, so you should be free to speak.
Oh, thank you. I appreciate it. This is Roger Lynn. I'm an attorney with the Center for Biological Diversity. We're a party to this proceeding. For this comment, though, I'm going to take off my advocacy hat and put on my subject matter expert for the community engagement subgroup for the DAC advisory group hat on. And just wanted to, illustrate, I think it's an admirable task to try and educate all DACs and ESJ communities on how a DSO system works. But I think back about this morning's presentation and then what spilled into the afternoon, and even Dr. Christoph's proceeding, which was, very much geared towards like trying to get a layperson's understanding of these very technical issues. And without resources to level the playing field, I worry it is an unfair endeavor to try and educate folks on how the DSO works and then have folks propose a DSO specific model. I think the resources should be being put in and focused in on developing community energy, figuring out what community energy needs are and how DERs can present solutions for DACs and also to reach our climate goals as well. We have very limited resources to do this endeavor, and I definitely encourage everyone to look at that aspect of it instead of trying to craft a giant community college curriculum on how the grid works, which I worry will be a futile lesson that could, in fact, discourage community engagement. But again, I am just one of the members on the advisory group, and encourage everyone to encourage folks to welcome the full advisory group to have discussion on this. There are not enough parties to this proceeding that focus specifically on DAC communities or ESJ communities. So I think pulling in the DAC advisory group is a good idea, and I will be sending that email to ALJ Himes soon to try and get the procedural schedule remedied so that we can have that input.
Thank you, Roger. On the Sam White just let us know that finding the raised hand feature might be hard. He had to click these three little dots at the bottom of the screen to find that raised hand. So let us know by chat if you just can't find it. Robert Perry apparently can't find it either. Roger, I'm going to unmute you again. Let us know, how did you raise your hand? Did you right click your name, or did you find a little raised hand feature?
It looks like a high five, which is on the bottom of the panelists, on the participant panel under panelists.
So you have to open your participant bar, and it's a very small button that is next to
Robert Perry, since we're running, sorry to cut you off, but Robert, I have unmuted you.
Oh, okay, great. Can you hear me?
Yes.
Okay, great. Great event discussion, a lot of material, a lot of landscape. Just a couple of comments. It just seems with regard to, physical DER assets, the utilities had the slide showing the progression down to the distribution substation and then distribution lines to the end user. And most DER benefits and transactions and sharing is really going to happen within those distribution lines from the distribution station, and more likely within a segment of that circuit feeder line. That's where the opportunity for energy sharing and things of that nature are going to reside. So my only suggestion is, to the extent possible, when you're talking to communities, it would be good to offer up representative situations, opportunities that are representative in most communities that people can see visually and identify with, and that would, I think, help people connect a lot of these abstract concepts to their community, or an aspect of their community that they can relate to. So I just would encourage going forward, to express things in terms of the experience that community members will be receiving from this new system, and how that can work and how they can be a part of that, because I think that people need to see their role and function, as Dr. Christoph stated, they need to be able to see that to really become motivated and excited to be part of the solution. So it's just something to think about. Thank you.
Thank you, Robert. I don't see other hands, and I think we probably should try to wrap up on time. So I'm going to go ahead and share this last slide. And Commissioner Houck, I'm going to, you can unmute yourself when ready. I'm going to share this slide. I'm actually having trouble sharing now. Wouldn't that be a great way to end today? Geez. Oh, I'll make myself the presenter. That's probably why. Okay. There we go. Okay, next steps.
Okay, thanks, Rob. So I wanted to thank everyone for staying with us through the end of today's workshop. We covered a lot of material today, and I hope the information was helpful in both providing a better understanding of how a DSO works and why a DSO is so important to ensuring effective DER growth as we anticipate seeing a tremendous expansion of DERs on the system. I also hope that the workshop was helpful in providing more information on what we're proposing for community engagement in the proceeding. I appreciate all of the comments and the discussion that we just had. I'd like to briefly go over the next steps following the workshop. And we have comments on Track 2 outreach plan, including any additional questions. Are currently due August 31st, 2022, with reply comments due on September 9th. I do note that Roger had made a request and will be reaching out to the ALJ regarding logistical procedural reasons why the Disadvantaged Advisories Committee may not be able to provide comments until later in September. So we'll keep you posted on any changes. Energy Division is going to also re-examine and revise the outreach plan as appropriate based on the comments to the ruling and the input received in today's workshop. The commission is planning to issue a ruling to set out the final Track 2 outreach plan in the very near future in early September, and we're looking to schedule listening sessions in the September-October timeframe. And as you'll note on the slide, we're requesting you contact Matthew Tisdale, and his email is there, and copy Kate Griffith by the end of August or as soon as possible with interest in listening session participation or to suggest participants. And then we'll be issuing a listening session summary in November. Community engagement needs assessment, scope of work development workshop will also occur in November. So those are our next steps in this process. And before we end today's workshop, I'd just like to re-emphasize the importance of meaningful stakeholder and community engagement in the proceeding. I know as folks have noted, this is a very technical topic and can be challenging, but we need to re-envision the way we're using energy, and our distribution grid planning is going to play a major role in allowing us to better utilize and incorporate DERs into our energy mix. DERs again include energy efficiency, distributed renewable generation resources such as solar, energy storage, demand flexibility, electric vehicles, and demand response technologies. So your input, community engagement and input is going to be an integral part of the process for assessing what the distribution grid of the future looks like, and will help inform our decision making in the proceeding. So with that, I'd like to personally invite the community members and organizations to participate in the listening sessions that will be scheduled, provide written comments, and reach out to provide feedback on the issues presented in the proceeding and how we can best develop community engagement tools to ensure that we make informed decisions on these important issues. And again, I want to thank everyone for your participation in today's workshop.
Yes, thank you for joining, and we are going to end on time. There is a form here to provide feedback. There are a series of questions. It's both in the slides, and the link has been chatted out. Anything to note about that form, Matthew, or have I got that covered?
We got it covered.
Okay. Well, we'll end a little bit early, and thank you, everybody.
Also, just thanks again to all our presenters, and thanks to the CC for partnering with us and presenting today. And thank you, Commissioner Houck, for your leadership. And thanks everyone for participating. Many thanks. All right.
Yeah, and
Contact
thanks
information. Yeah.
to all of you for facilitating and putting the workshop together. Gabe, Rob, Matt.
All right, I'm going to stop recording, and everybody have a great rest of the day.
Thanks.